A confirmation about the audio, please, guys. If the audio is clear and audible. Thank you. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep IAS. Welcome to another session of climatology, where today we shall be looking at few of the atmospheric phenomena furthermore, and then we shall be using all the concepts that we have been studying in the portion of climatology. We shall be putting them to use, and then we shall be trying to understand the portion of the most complex atmospheric phenomena of them all, and that is the Indian monsoon and the Indian season. Now, here, when we talk about the various different atmospheric phenomena, so what is it that we studied yesterday? So, yesterday, basically, we looked at the aspect of what do we understand. First of all, we started with the naming of the cyclones, the naming of the tropical cyclones. Then we started looking at the aspect of how is it that we have a circulation across the same latitude. And with the help of that, we try to understand the details of what do we mean by the Walker circulation. Now, in the case of a Walker circulation, we observe that it is a longitudinal circulation which happens between the eastern and the western part of the Pacific Ocean, equatorial Pacific Ocean in general, and south equatorial in to be more specific. Now, here you have the influence of the trade winds, and these trade winds, as they move from east to west in general directional movement, that is where they carry the surface water along with them, and the surface water being the warmest of them all. Now, that warm surface water, as it is carried, it keeps on getting accumulated in the portion of the Western Pacific Ocean. Now, once they get accumulated in the western part of the Pacific Ocean, that is where the accumulated warm waters, they end up creating a large warm water accumulation pool, and that is what creates a low pressure condition. Now, this low pressure condition attracts winds from all different areas. The winds will start rising up after converging, and then after hitting the tropopause, that is when they diverge. Now, as these winds are coming over to the region of the western part of the Pacific, in the meanwhile, in the eastern part of the Pacific Ocean, as the surface water is drawn away, the subsurface water exposes itself by a process what we refer to as upwelling. Now, we saw that upwelling ends up reducing the temperature quite significantly in the case of the surface. So, across the two poles of the Pacific, or two ends of Pacific, you have the presence of a cold water region in the eastern Pacific and a warm water region in the western Pacific. Now, that creates a high pressure and a comparative low pressure, which is enough to sustain a longitudinal circulation, that is between different longitudes across the same latitude, and that will have its implications, and that circulation what we refer to as the Walker cell or the Walker circulation. Now, that Walker circulation will also have a kind of a circulatory arm extending over to the region of the Indian Ocean and furthermore as well. Now, further ahead, we took a look at the portion of the ENSO, and we understood the ENSO phenomena. So when we take a look at the ENSO phenomena, there we observe that you have in the region of the Pacific a variation of climatic conditions from El Nino to neutral to La Nina, and that keeps on oscillating between these three conditions. And that is what we have as the El Nino Southern Oscillation. Now, what is it that we refer to as a normal condition of that ENSO cycle? The normal condition is nothing but a Walker circulation or a Walker cell which is created, and then sometimes it gets intensified where the region of upwelling significantly increases, creating a cooling phase of the Pacific, what we refer to as La Nina conditions. So La Nina conditions are an intensified form of Walker circulation where the winds will get much more stronger, the low pressure across the region of the Western Pacific will get much more larger, much more intense, and the high pressure across the region of Eastern Pacific will also significantly intensify. So that creates a kind of a circulation across various different longitudes. Now, after that, we tried to understand, and we also took a look at what do we experience as a weather phenomena in the case of La Nina. So in the case of La Nina, the Peruvian coastline is something which receives very heavy amount of rainfall. And then when, or rather, pardon me for that, the Peruvian coastline would experience very dry conditions, and the Australian coastline would receive very heavy rainfall in the case of La Nina. And Indonesian coastline, Philippine coastline, every area, because of the spread of the warm water, would receive very heavy rainfall. Then, sometimes, due to certain conditions, the trade winds they weaken or they come to a standstill. Now, as these trade winds they weaken or come to a standstill, that is where all the accumulated warm water starts to flow back. And as it continues to flow back, those warm waters which have been accumulated in the Western Pacific, they will come across to the region of the Central or to the Eastern Pacific Ocean. And that creates a reversal of the Walker circulation, where this time now you have warm waters present in the region of the Eastern Pacific, and then that attracts the winds that creates upwelling and colder water region in the Western Pacific. So that is a reversal of the Walker circulation. That is what we refer to as El Nino. Now that El Nino, which is always associated with dry conditions over India, will end up creating dry conditions even over the region of Australia, and will end up creating significant amount of rainfall over the Peruvian coastline. And then we took a look at the portion of a kind of a similar difference in temperature, similar difference in pressure created over the region of the two ends of Indian Ocean, and that is what is referred to as the Indian Ocean dipole. Now, the Indian Ocean dipole, basically, we observe that Indian Ocean dipole is what? It is a difference in sea surface temperature between the eastern and the western edges of the Indian Ocean. Under normal circumstances, the eastern part of the Indian Ocean that is surrounded by islands and significantly large number of islands, so that eastern portion of Indian Ocean will accumulate greater amount of heat because of the lack of circulation, because it is present between the islands, trapped between the islands. And that is when, as it gets heated up, it will create a low pressure region. And this low pressure, which is created in the Eastern Indian Ocean, will attract winds from all sides. And that is where it will also pull the winds from the region of the Western Indian Ocean, creating upwelling or a kind of a high pressure condition in the Western Indian Ocean. So that is what you have as the normal phase of IOD. Now, this can get intensified just like how Walker cell intensifies into La Nina. So this normal phase can get intensified into a another phase, what we refer to as a negative phase of IOD, where the intensity of the low pressure across Eastern Pacific goes much stronger, and the intensity of high pressure across the Western Indian Ocean, rather, that also grows much stronger. So the intensified normal phase is what we experience as the negative phase of IOD. Now, this negative and the normal phase of IOD, they will be detrimental to the Indian monsoonal rainfall, and the amount of rainfall received in India, especially during the monsoon months, it reduces whenever you have the condition of a neutral or a normal and negative IOD. The situation reverses sometimes when you have a significant heating of the Somali coastline as well as the Arabian Peninsula. So there is a creation of an entire warm water pool because of the heating of the landmass. So nearby water body also gets heated up. So warm water pool gets created in the region of the Western Indian Ocean, and that reverses the normal circulation in IOD, and that is what is referred to as the positive Indian Ocean dipole. So that positive Indian Ocean dipole, it is something which is beneficial for the monsoonal rainfall received in India. That is something that we had looked at yesterday. Now today we initiate with the discussion with a very unique phenomena, that is the Madden-Julian oscillation. Then we will take a look at it at the portion of jet streams, the formation, the presence of the jet streams. And then after that, we shall be taking a look at the Indian climatic condition, Indian monsoons. What do we mean by the monsoonal rainfall? That is dependent on which characters and which properties. And then after that, we shall also be analyzing western disturbances and phenomena like that. Okay, so we continue with the portion of Madden-Julian oscillation. Okay, uh, positive IOD is not going against the trade winds. It is the negative IOD which goes against the trade winds. Positive IOD very much is associated with the movement of the trade winds. Okay, so here till now, what we have seen in the case of normal Walker cell and Enzo cycle, and also in the case of Indian Ocean dipole, is development of two different pressure zones or pressure cells across both ends of the ocean. And in between that, you have a circulation which is attained. Okay, that is the circulation that we have observed in the case of the Indian Ocean as well as the case of the Pacific Ocean. We have seen that circulation happen in the Indian Ocean or IOD because of the two different pressure zones which are created at both ends of the Indian Ocean. And also in the case of the Pacific Ocean, we have seen the Enzo circulation because of two different pressure conditions developing at both. So these are fixed pressure zones. But you have also a kind of a traveling pressure system. And that traveling pressure system is basically what we refer to as the Madden-Julian oscillation. So basically, it was in the 70s when you had two climatologists and meteorologists who traveled to the region of Singapore to study the amount of periodic rainfall received in these equatorial areas, and also because equatorial regions receive very significant amount of rainfall and regular amount of rainfall, and also the rainfall which is caused, how it is impacted by the Pacific Ocean, heating cooling of the Pacific Ocean, Walker cell, etc. Now, while they were carrying out their studies in the region of Singapore and in the surrounding islands, they observed or they came across a very unique pattern. They observed that after every few days, around 30 to 45 days, they would encounter a very heavy bout of rainfall in the region. That would be followed by dry conditions. And again, after again another 30, 45, or maybe 60 days, you again had a significant bout of rainfall which was received. Now, this is something which they understood was a creation of a pressure zone which might be occurring repeatedly. Obviously, when you have rainfall happening in a region, it can't happen because of high pressure. Rainfall happening in that region would always be a resultant of a low pressure. So they were almost sure that you have some amount of that low pressure which keeps on coming repeatedly in these tropical and equatorial regions, which is causing that rainfall and periodic rainfall. Now, they further carried on that study, and they actually found that in the region of the tropics, closely to the region of equator, you have a traveling pressure system. In the case of IOD and ENZO, we saw that the pressure systems, they are fixed at both ends of the ocean. So here they found that other than this as well, around the equatorial region, there is a pressure system which travels due to and owing to the rotation of the planet. As the planet rotates across its axis from west to east, that is why, and that is when even these pressure systems, they travel along with the rotation of the planet. And what is this traveling low pressure and high pressure system in general referred to as? They are referred to as Madden-Julian oscillation. And Madden and Julian based upon obviously the individuals who chanced upon this particular discovery. So here, when we say a traveling pressure system, what do we mean by that? So that basically tells you a situation which is, if imagine this is the surface, so you have a low pressure. This low pressure would attract winds. Wherever you have significant low pressure, it will cause rainfall. Then these winds will diverge, form very large cells. Eventually, at some places, they would sink as well. As they would sink, in these areas, they would have high pressure. So this is the pressure system, low pressure surrounded by two high pressure. And they basically observed that this entire pressure system in itself, that is traveling from west to east. Okay. That entire pressure system in itself is traveling from west to east, aided obviously by the rotation of the planet. The planet rotates in around its axis from west to east, and in the equatorial and in the tropical region the rate of rotation is also very very fast. So that further aids the rotation which is observed, or that further aids the movement of this pressure system. So when we say a traveling pressure system, means what? It means that, let's suppose today you have a low pressure here and high pressure condition in these areas. It might happen that after a few days you have the low pressure system which comes over in this area, and this region becomes a high pressure. Then you will have another high pressure here. So the entire thing and the entire phenomena in itself gets translated. So that is basically what is observed in the case of Madden-Julian oscillation. So here, basically, MJO is an eastward moving disturbance of clouds, rainfall, winds, and pressure that traverses the planet in the tropics and returns to its initial starting point in the span of 30 to 60 days on an average. Each cycle approximately lasts for 30 to 60 days in general. Okay, so that is why oftentimes it is also referred to as basically the 30 to 60-day oscillation. It is also referred to as, or it can also end up repeating itself in 45 days. So somewhere in that region. Okay, so here, uh, basically, if I could indicate by animation, what I would show here is that this, as the planet rotates, so here you have the low pressure. Now this low pressure would be aided by high pressure on both sides. High pressure on both sides. And this entire disturbance in itself would travel from the direction of west to east as the planet would rotate. Now, this would be other than the portion of IOD. This would be separate from the ENSO circulations, and this would be a new phenomena altogether. Okay, so here, once the air comes towards that low pressure, it will rise up, it will reach the region of the tropopause, it will diverge. When it diverges after spending some time in tropopause, obviously in the region of top of troposphere, its temperature would reduce quite significantly and drastically, and then it would cool down and eventually settle down and sink. So that is where you have the kind of circulation. Now, this entire circulation is referred to as MJO. So after every 30 to 45 days or 30 to 60 days, whichever region this low pressure would lie into, that is a region which would receive heavy bouts of rainfall. And whichever region this high pressure cell would lie into, those areas would receive dry and fair weather conditions, complete lack of rainfall. So that is the circulation which is attained. So, a kind of an MJO is said to have two various different phases. So, MJO will have two different phases. One is phase of enhanced rainfall, that is the low pressure phase and phase of suppressed rainfall. That is referred to as the high pressure phase. Okay, so here you observe this is your entire circulation that you observe. So in the region where, let's suppose, you have low pressure, the low pressure system here. So here you would observe significant amount of convergence rising of the air, formation of very dense cloud, very heavy occurrence of rainfall, and then it would diverge immediately after that and it would sink. So in the region of the high pressure, this is the region of a suppressed rainfall. So in the region of that high pressure, you would experience sunny and dry conditions, whereas here in the region of the low pressure, you would experience stormy and wet conditions. That is generally experienced. Now, obviously, you don't need to know about the various different stages, but lately the climatologists, they have been able to decipher the various, there are 8 different stages or 8 different phases of even this MJO circulation, and you have the various different phases as it moves and covers the region of the Indian Ocean, then it covers the Pacific Ocean, then very briefly it will cover the Atlantic, because Atlantic is narrower at the region of equator. So that is where it will cover the region of the Atlantic, and then again it gets created in the region of the Western Indian Ocean, in the region of Africa. That is where it gets created. Again, that low pressure will get created, and that again will start traveling due to the rotation of the planet. So, that is your concept of the traveling pressure system, which is referred to as MJO. Now, this traveling pressure system will also have an impact on Indian monsoonal rainfall. So, that is why it is something which is important for us to understand for only the purpose of the Indian monsoon. That's it. So here, the enhanced rainfall phase and the suppressed rainfall phase. Okay. Now, again, I would say even this basic feature that you would know would be much more than sufficient for your general studies preparation. Okay, UPSC is never going to ask you the reasons for the formation of MJO, because this is a climatic reality that our scientists, our climatologists are also working hard upon. As of now, you have a project initiated by US, and also few of the Indian scientists and Indian Meteorological Department is also working on a project to try to find out whether there is any linkage between the occurrence of MJO and the occurrence of ENSO cycles. So we still have not completely been able to understand this phenomena, but nonetheless, here you have it. So that is your low pressure and the high pressure. So here you have the high pressure. It happens every 30 to 45, 45 to 60 days. Yes. Obviously, my dear friend, these are not in NCRTs. These are not something that you will find even in your reference books. So now, for those of you who have the basic aspect or the issue that why it travels from west to east, so think about it very briefly. So, and again, I would reiterate, re emphasize the fact that this is not going to be asked in your GS preparation, but then it is something that is relevant in terms of your current affairs. You would come across the MJO impact on Indian monsoon quite frequently, cyclonic formation. in Indian monsoon is something which is observed quite frequently. So this is where it will get very strong in the region of the Indian and the Pacific Ocean. It dissipates and weakens and disappears over almost over the region of Atlantic. Then again germinates in the region of the Western Indian Ocean due to heating of the portion of African mainland. That is where that low pressure gets all created. And that is when, if you have a low pressure, winds will be attracted, and that will have its own different arms of sinking air as well. Now try to understand how is it, or if it is possible for you to find logic here, that will it travel to east or from one direction to another or not. So here let us understand, for example, in the region of low pressure. So in the region of low pressure, you will have very heavy occurrence of rainfall. And we are talking about tropical areas. Here you will observe sunny and dry conditions. Okay? Because of the high pressure. Now, if I ask you that when we talk about the temperature condition in the low pressure, after receiving rainfall, we can expect that the temperature condition in this low pressure, it will slowly and steadily, because there, whenever you have continuous occurrence of rains, what will happen to the temperature? It will reduce. The temperature will reduce. It will start to cool. Starts to cool down. Then in this region of high pressure, you have sunny and dry conditions. Now, when you have the presence of sunny and dry conditions and lack of rainfall because of high pressure, what will happen to temperature in this area? The temperature in this area will begin to rise, starts heating. Now, because it is sunny and dry and lack of rainfall, so that is why it will start to heat up. It will start getting warmer. Now here you have a heating which is observed. Here you have cooling which is observed. So after some time, you will have the transition of the pressure, that in this area, in this wider region, you will experience that because of lack of rainfall and heating, this area starts developing a kind of a low pressure. Right? Whereas this region, because the temperature has reduced quite drastically due to continuous rainfall, this gets translated into a comparative high thermal pressure. So once you have a translation of that low pressure to high pressure, and here high pressure to low pressure, so now the wind direction will be coming over here. So now you will have the convective phase, or the phase of enhanced rainfall. It has traveled eastwards. So that is how further this process will be repeated. Excuse me. So further this process will be repeated, and this process continues to carry on. It takes around two phases of the MJO, three phases of MJO to completely end up translating over the region of the Indian Ocean. Then in the other two phases or three phases, it moves over the region of the Pacific. And in the final phase, it translates itself over to the region of the Atlantic, because the Atlantic is smaller. So that is where you have the high pressure which gets heated up over a period of time due to lack of rainfall. Low pressure, because it is receiving continuous rainfall, starts to cool down, and that is how the entire movement from west to east, aided by the rotation of the planet, that is something which we refer to as an MJO. Okay, so that is what we have as an MJO. So eastward movement movement is also aided the rotation of planet. So planet also rotates in which direction? From west to east. It is observed throughout the year, and that is where you will observe that this particular translating system or this particular pressure system, it ends up moving in a general direction of west to east. Okay, so here suppose you have the low pressure, then after a few days that low pressure system will translate into this region. After a few days, furthermore, it will get translated into the region of Pacific, and wherever this lies, that is where you have the condition of low pressure. If it lies in the region around Bay of Bengal will experience the formation of a tropical cyclone. If it lies over the region of Arabian Sea, then that also will experience the condition of a tropical cyclone. So that low pressure created by MJO, when it lies over the region of the Indian Ocean, Central Indian Ocean in general, and Western Indian Ocean in general, it aids to the monsoonal phenomena and the monsoon rainfall which we receive. Okay? Now, after that, we come across another interesting and complex phenomena again. That is what is referred to as jet streams. Now, the understanding of jet streams in itself is something which is very new, in the sense that we came to know about these jet streams only in the past century. Before that, we had no clue about what these jet streams are or whether there is an existence of jet stream at all. So these jet streams, when we talk about, so what are they and how do we know about them? So initially in the 1920s, for the first time, you had a French climatologist who actually studied with the help of a balloon experiment. And with the help of the balloon experiment, he observed and he came to a conclusion that there is a strong wind velocity and a strong wind motion observed in the upper region of the troposphere. But then greater amount of research could not be carried out, and then eventually that research could not be proceeded further. Now the Second World War came. Now when you had the Second World War, at that point of time, what was experienced, just a moment. So when you had the Second World War, at that point of time, you had basically Japanese attack into United States. And when Japanese they attacked the region of the United States, they moved across the region of the Pacific and they did bomb the region of the United States. Now in retaliation, United States launched an attack on Japan, and they would launch their heavy bombers, very heavy bombers, and they would travel, few of them, all the way to the region of Japan. Now these airline pilots, when they came back, they reported something which was rather very interesting. They basically said that, look, when we are moving towards the region of Japan from United States, when we are moving towards the region of Japan, that is in general a direction from east to west. So whenever we are moving in that direction, our speed is reducing. And then when we are coming back to the region of United States, there is an extraordinary increase in our speed. So this was reported. This was reported to the air headquarters. Now, air headquarters will have many of the climate experts as well, and the weather forecast is done to the last degree in order to aid the movement of these planes, in order to aid the movement of the pilots. Now, upon receiving these reports, it was reported uniformly that when we are moving from east to west, our speed reduces. Whenever we are moving from west to east, our speed suddenly increases. Earlier, for a few moments of time, it was thought that it is a phenomena of the Pacific, because Pacific being such a large ocean, you have very unique phenomena, localized phenomena which come into existence. So it was discarded as that. But when you had air operations being launched in the region of Europe, there also something on the similar note was observed. It was basically observed that there also, as the pilots would move, or as the planes would move from the region of west to east, their speed would increase. But when they would move from east to west, their speed would reduce substantially. So, upon greater investigation, it was found out that indeed, in the higher levels of troposphere, in the region of troposphere at various altitudes, you indeed have a very strong moving wind, a strong wind which moves in the direction of west to east. That can influence the movement of the fighter planes as well. So, that is how strong these winds could be. And hence, they were referred to as jet streams, right? Because obviously, influenced by the naming was influenced by the impact that these winds had. So, overall, in simple terms, these are high altitude, fast moving winds from west to east. Yes, if you have taken a look at it on YouTube, we have created an animation series for jet streams. So I think yes, Sawmill. So there, with the help of animations, we have covered it. So I hope that is productive. So for any one of you who you want to understand this by the process of animation, we have, and I don't know how many of us are aware about this. So we have launched a entire series of geography and history videos which are present on YouTube, uploaded on YouTube. So any portions of geography that you want to get clarity upon, you can find it on YouTube. Please give the link. Right. Should I show the video with the help of the video camera as well? No? Okay. Like that, you will explore the internet like anything. And when I say that show, do search it on YouTube, it is as if I'm telling you to go and on top of Himalayas and carry out a hard work. So there, if you are unable to find that simple search in the Byju's IS channel, then well, the examination of UPSC is going to welcome you with open arms. So that is where it is present on YouTube. So those of you who can do that basic amount of work, you can search there. Otherwise, this session will also be very sufficient. So here, when we talk about this, these are the moving winds in general from west to east. So these fast moving winds from west to east, that is what we refer to as jet streams. So for a very long period of time, it was not understood that why these jet streams, they do exist. Where do they exist? Why do they get created? And eventually, what are their features? But over a period of time, due to significant amount of climatological studies that we have been able to carry out, we have understood it in a fairly fair manner, where we have found out that these are actually narrow streams of very fast moving winds at a greater altitude, whose height also ends up varying, whose position also keeps on varying. But these are like rivers of very fast moving wind direction. That is what is referred to as the case of jet stream. So here, when we take a look at jet streams, these are relatively narrow bands of strong wind in the upper levels of the atmosphere. By atmosphere, here we refer to the troposphere. Okay, so that is where you have the narrow bands of strong wind in the upper levels of troposphere itself. Now, generally, the winds would be moving in a direction of west to east, and here they have a streamline flow with very high velocity winds. When I keep on repeating high velocity winds, what velocity am I talking about? Is basically that in the center, in the central portion of the jet streams, oftentimes the speed is found to be around 250 to 300 kilometer per hour. But sometimes the speed can exceed to even around 400 kilometer per hour. That is how much the speed can exceed into. Okay, so they travel in the tropopause, around the tropopause in certain cases, and they have a variation in height which is experienced. So they end up having a variation in height, they end up having a variation in their latitudinal position as well. Okay, so here the strong air currents, which tend to look wavy and like striated or striped rivers when seen on a jet stream map, they get created wherever you have the cold air and the hot air when they meet. That is when they get created, and you have these narrow bands. So if you have to imagine the condition of these jet streams or the entire movement of these jet streams here, you have to understand that basically, if suppose this is the land here. Now, let's suppose this is where your tropopause lies. Now, these jet streams, they will have a wavy nature, right? Where sometimes their height can go up as much as around even 12 to 15 kilometers. Sometimes their height can reduce to even 6 kilometers from the ground surface. So there is a kind of a striated, a wavy pattern which is generated. And also, it is not only the wavy pattern or not only the vertical variation that they go through, you also will find a kind of a horizontal variation. For example, observe here. This is just an artistic recreation. This is not where actually you will observe these jet streams, but just an artistic recreation. So here you will observe that it moves northwards here and it moves southwards here. So you have both the northward southward variation, and you also have a kind of an upward downward variation. So it is a kind of a three-dimensional variation if you can observe or if you can imagine it. So it will imagine if there is a kind of a wind pattern which is moving. So wind pattern, if it comes towards you, comes back, dips, comes back, goes up again, comes towards you. So it is a kind of a three-dimensional variation that you will observe. Okay. Now this creates very long pattern of wind movement, which can have a width or which can have a length of close to around even thousands of kilometers at one go. Now they are created when hot and cold air, they end up meeting. Now, in this case, when we talk about these jet streams, they get created across the entirety of the planet in certain areas. So here, let us understand, first of all, how they get created. Again, I will tell you that for your general studies, UPSC is never going to ask you that how these jet streams get created. But again, curiosity, I understand curiosity kicks. You want to know how it gets created. So that is why we'll talk about it in very brief. So here, let us understand the basic aspect of it. So, before that, no, it is generally not present around equator, Aditi. So, this is just an artistic recreation. Before that, let us consider the situation where I have hot air and I have the presence of cold air. Obviously, cold air will have a lesser volume as compared to the warm air. Warm air will end up experiencing or indicating a much greater amount of volume, right? Warm air expands. Where is it present? I will come to it. Don't worry. I'll come to it. As of now, just pay attention to the screen. Just pay attention to the screen. Leave anything else that you are looking at. Just pay attention at the screens here. Okay. Now, this is the region of cold air. For optional also, the portion of jet stream that we are going to cover in this portion, that is more than sufficient. In fact, in this entirety of the module, what we have studied, that will be something which will be sufficient even for your optional preparation. Okay, if we combine this particular area with some parts of oceanography, that is more than sufficient for your optional. So in majority of the areas, if you are following the logic, we are taking the level of discussion to an extent that even optional preparation would be justified by that. So obviously general studies portion would obviously be justified by that. So here you have warm air. Now, if I ask you and understand, try to understand this logic, try to follow this logic. Now, if I ask you that at a position, if I compare 1 and 2, which will indicate a higher pressure, 1 or 2? Always it will be 1, isn't it? You have cold air. Cold air exerts more weight. So always here you will have high pressure. Perfect. Here you will have low pressure. Now, let's consider this at a greater height of 5 kilometers, 6 kilometers, any assumption that you take. Now, if I ask you to consider the difference in pressure in the region of, let's say, here A and here B. At this particular height, where do you think there will be a high pressure? Good. Very good. It will be in the region of B. Why? Because regardless of the less density of air, here you have much more number of particles which are present in comparison to the number of particles which are present here. So always you will have a kind of a high pressure created here. Here you will have a kind of a comparative low pressure. So observe how on the ground surface you have a pressure condition which gets varied when you go higher up, right? So at a higher platform, it gets varied significantly, isn't it? Now, in this situation, you have a high pressure. Here you have a low pressure. So in between these two columns, can I expect a pressure gradient force? Can I have an expectation of a pressure gradient force here? Yes, you will have a difference of pressure, so a pressure gradient force will come into existence. When you have a pressure gradient force coming into existence, that will initiate what? A wind movement. Always it will initiate a wind movement. So the wind will rush in. Okay? Now the wind rushes in towards this direction. Will it get impacted by the rotation of the planet? We know, and before that, we will talk about the rotation later on. What will be the speed of wind in this region? We are talking about an altitude of 5, 6, 10 kilometers higher. What will be the speed of the wind? Very, very high. The speed will be extraordinarily high because frictional force will be almost absent. Now, when the speed is high, what do we know about the bending due to Coriolis force? Will the bending be greater or will the bending be lesser? What do you think? Bending will be very great, very significant amount of bending, isn't it? Now, if I tell you the same aspect, let's suppose I have cold air, cold polar air in these areas. And then if I tell you I have warm tropical air coming in these areas, which will occupy a greater volume. Can you imagine a scenario or a circumstance where what will be the movement of wind? Right? From the region of warm to cold. So from the region of warm to cold, the winds will blow with a very high speed. But then the bending will be quite significant. So what will be the direction? Can I have a direction like this? Isn't it? Can I have a direction like this because of significant amount of bending? Perfect. Is that logic understood? Very good. Now, similarly, in the case of the southern hemisphere, apply the same logic. In the case of southern hemisphere, let's suppose you have the cold polar winds and you have the warm winds here. Right? So what will be the direction of motion of the winds? From warm to cold. But here they will get deviated to the left. So what will be the direction of the wind? They will get deviated to the left. So can I have a motion like this then? Can I have a motion in that direction? Right? So that is your creation of jet streams. Keep it simple, keep it easy to understand. You will never forget. Okay, so that is something which you have or which you experience in the region of higher altitudes. Now, these jet streams we have seen that basically these jet streams, they will have a kind of a wavy nature, upward downward wavy nature, and also north south wavy nature is something that you always associate with these jet streams. So why is it that this wavy nature is created? That is because the height of the warm air column that we have. So this is your hot air column. This is your hot air. Left should be the other way, is it? Look at it again. This is your cold air. Right? So we see that there's a difference in height between hot air and cold air. So wherever you have the interaction of hot and cold air, the now at every place you won't have the interaction at the same level. So that level of interaction will end up varying in certain areas. Let's suppose the cold air column is particularly downwards in certain, maybe a greater height. So that is where you have a vertical variation because of the height difference created between the warm air and the cold air. Now, why is it that we have a kind of a latitudinal variation of these jet streams as well? That is because in certain areas the warm air moves further. In certain areas the cold air will come to a greater depth. So that is why these jet streams, they will meander along the way. Okay, so that is what is understood by jet streams. Now, where will they occur? They will be observed wherever you observe or experience a difference in temperature at an upper altitude level, not on the ground surface, at an upper altitude level. Wherever you come across a difference in temperature, that in itself will induce jet streams. So, difference in temperature in upper altitude creates jets. Okay, wherever you have that difference in temperature, this jet stream will get created. I hope that is understood. Okay, simply can we say that air masses moving creates compression and expansion causing alternate? Yes, you can say that as well. That also you can have a conclusion. If we fly from India to West, it takes more time than vice versa. Depends if you encounter the region of jet streams only then. Okay, so these jet streams are restricted into certain areas. Which are those areas? So when you take a look at these jet streams, so they will be created only over the areas where you have a distinct difference in the temperature conditions in upper altitude. Okay, so for example, let's suppose if we consider the tricellular model of circulation we had seen here. So in this region, we consider only the northern hemisphere. So let's suppose this is your tricellular model of circulation. This is your subpolar low. This is your polar high. This is your subtropical high. And this is what is also the ITC set. Now, if I ask you in this area, in the upper altitude, between the two air columns and the air masses that we have, will we experience a difference in temperature in this particular region? What do you think? Will you experience a difference in temperature here? Why? Those of you are saying yes, why? Just a random guess, is it? So here you won't experience any difference in temperature. The reason being that in this area, winds which are coming from both sides, they will be coming from the region of tropics. So both of them will, because they are coming from the same area, they will indicate similar property. So that is why you have no difference in temperature which gets created in this area. So no jet stream presence around the region of ITCZ. Okay. No jet stream will be present or to be found around the region of ITCZ. Now, what about here? Will we experience a difference in temperature here in this area? Yes, significantly. Why? Because it is indicated in the diagram as well. Because here you have one air in this region coming from the region around equator, one portion coming from the region of the subpolar area, that is around 60 degree. Now both of them, they travel from very different latitudes, so obviously the temperature that both of them will indicate will be very different. So that is why here you will have a difference in temperature, creating that pressure gradient force. So across this area, across this subtropical high pressure zone in the upper altitude, you will experience the existence of a jet stream that is referred to as the subtropical jet stream. What about this region? Will there be a difference in temperature here? Good. Here also you will have a difference in temperature, because when the cold air mass also gets lifted up, it doesn't get lifted up in very large proportion, but the cold air parcel in this area in itself will be having a height of around 5 to 6 kilometers in general. The warm air parcel will rise up along with it. So in general, in actuality, what happens in this area is that in this region you have the cold air parcel having this kind of a height, and the warm air parcel keeps on rising and then diverging, right? So this is the kind of observation that you find in this region. So here in this area, the difference in temperature is very immense, very huge, very large difference of temperature. So the jet stream created here is very strong. That is the polar jet. This subtropical jet in comparison is weaker. Subtropical jet in comparison in various different seasons, it will get weaker. But the polar jet is persistently going to be present. And it is going to be present all around the region of poles. That is what is also sometimes referred to as a circumpolar jet, that it keeps on moving around the region of the poles. And when this jet stream weakens, the impact on weather condition is, well, something so humongous that you have many different manifestations, from the creation of heat waves in the region of Europe and Canada to the conditions of polar vortex that you observe, where sub-zero temperatures are created in the region of North America. So the impact is quite immense. Now, coming to another basic concept here. When we talk about, let's suppose, when we talk about these jet streams, so we can see that these jet streams are influenced by air circulation. So in between various different seasons, we observe a shifting of the pressure belts. That is what we observe, and I hope we are comfortable with that. So we have seen that in the summer season, all the pressure belts, they shift to the north. In the winter season, all the pressure belts, they shift to the south. We have seen that. Now, will the jet stream shift along with them, or will the jet streams be permanently fixated in a place? What do you think? Good. So jet streams also shift along with them. So jet streams also shift from north to south and south to north with the variation in seasons. That variation will happen. But then it is not completely linked with the shift of the pressure belt. Sometimes what happens, pressure belt shifts, then the circulation in the upper air shifts slowly. That is when slowly the jet stream will also shift or will disappear. Again, sometimes again the pressure belt will shift, the jet stream takes its own time to come to the south or to the north. Now, by the way, again something that we discussed in in the last couple of classes or two classes back. So when is it that these jet streams will be more prominent, summer or winter? What do you think? Very good. These jet streams are more prominently to be found during the winter season. They are much more stronger during the winter season, because it is during the winter season where the difference of temperature between the lower and the higher latitude, that gets exaggerated. So that is why jet streams are going to be more prominent, much more stronger during the winter season. So they shift with the shift of the pressure belts in the region of north or south. So they are stronger in winter in the northern and the southern hemispheres, because that's when the temperature differences that drive them tend to be most pronounced. Actual appearance of jet streams results from the complex interaction between variables such as location of high and low pressure systems, warm and cold air, and also seasonal changes. They meander around the globe, dipping and rising in altitude as well as latitude, splitting at times and forming eddies of circulation and even disappearing altogether. So here, with the seasonal changes, jets shift from south to north and vice versa. Now, they will have a significant influence over the weather conditions. You will observe that how these jet streams are moving, right? So you will observe that these jet streams, as they are moving, they form very complex interactions. So here they can split. Now, it is all dependent, my dear friends, on the presence of warm and cold air column. Okay, if you want, I will tell you again about the warm and cold air column. So understand this. Once you understand that basic perspective and that basic about the warm and cold air, right, you will never forget this. So here you don't need to be learning this. Always I tell you, please don't try to have an effort where you start learning things. Don't learn this. Try to understand it. If you have a warm air here, and if let's suppose you have the presence of cold air somewhere here, cold air will have a much lesser volume as compared to warm air, because warm air is much more expansive. Okay. So again, I will tell you, this is a repetition that I am doing because consistently I see many of you are asking why moving from warm to cold. So again, I will tell you, and listen to this carefully. So here on the ground surface is basically what? This is the cold air. So this is the region of high pressure. This is the region of low pressure. Isn't it? On the ground surface. But when we talk about here, in this altitude, this becomes a region of high pressure because of greater volume. This becomes a region of low pressure. Then you will observe the movement of wind because of the pressure gradient force in these areas. In between these two, you will have a pressure gradient force at this altitude which will get created, and that means the movement of wind will happen from here to here, and that will induce obviously a kind of a movement, and that will be deflected owing to the Coriolis force. Okay, is that understood? How pressure difference occurs, because here you have a very less amount of air volume above it, here you have a very large air volume above it, so obviously the pressure exerted at this level will be higher, pressure exerted at this level will be comparatively lower. So that will induce the, due to the temperature difference, this will induce the pressure difference at a greater altitude. Okay, so that is how temperature difference induces a pressure difference, which induces a movement, and that brings about the existence of jet streams. Okay, now after this, we basically come across the entirety of the planet. So in the entirety of the planet, as we have seen the tricellular model of circulation, so it is in those zones of transition in the case of the tricellular model of circulation where you will observe the jet streams to get created, where you will observe the jet streams to get formed. So you have subtropical and polar jet stream getting created in each of the hemispheres. So when we talk about it in the planet, so just like the permanent wind systems and the permanent circulation of air that you have, so there also exists a set of 4 permanent jet streams, 2 in the northern hemisphere, 2 in the southern hemisphere. So you have, Harmeet, is it a kind of an agitation that you are launching, that if you will write PYQ 50 times, then suddenly we will take up PYQs? Is that the agenda here? That keep on repeating PYQs, then they will take PYQs, they will stop the discussion, and they will suddenly take PYQs? Have you understood the portion of jet streams? No? Okay. Have patience. I understand with the PYQs you get that feeling of that fastest finger first and the getting, and immediately you will say that share the leaderboard. I understand that feeling that you get, but it is important to understand the concepts first. Okay, once you understand the concepts, I will give you enough PYQs to play with. Okay. Now, here you have basically the various different jet streams. So you have four permanent jet streams which are present. So four permanent jet streams, basically you will have them in the zone of interactions. Wherever you have those zones of interactions, there you will observe these jet streams. These are your four permanent jet streams. Four permanent jet streams. So here, in the case of four permanent jet streams, which are those? Two in each hemisphere. So that is, you have polar jets. Polar jets will be created due to the difference in temperature created at subtropical, or rather subpolar low pressure belt. In that region, the polar jet will be created. So in the region of area of subpolar low pressure. Then you also have what is the subtropical jet. These are created over subtropical highs. Okay, so this is observed in both the hemispheres. Please keep that in mind. Observed in both the hemispheres. But these are not the only jets which are created. Now, the jets generally, you will find that the jets in general, they have a common phenomena. That is, they are moving at very high altitude and they are moving at a very high speed. That is the common phenomena. They move at higher altitudes, not necessarily always at the region of tropopause. They can take a dip even at the level of around 6 kilometers from the surface. So there will be a height variation, but there will be a very high speed. Now, as a result of this, sometimes whenever you have a high altitude, very strong movement of wind, they also are classified as jets. So just like in the case of the wind systems, we had the permanent winds and we also had the local winds. Here also you have the permanent jets and the seasonal and localized creation, what we refer to as the temporary jets. So you also have the presence of temporary. No, jet stream, Santosh, never comes at the region of equator. You also have temporary jets. Now, these temporary jets, they will either exist over a short period of time or they will exist over a short or a smaller region. For example, you have the Somali jet, which blows from the region of Somalia all the way towards the western part of Indian coastline in many of the cases. Generally not up till the coastline, but generally across the region of the Arabian Peninsula. And then you have the tropical easterly jet. Tropical easterly jet. This is also a temporary jet. Okay, so that is something which is observed here. Do they flow near the fronts? Yes. Many of the times they do. They do flow near the region in the case of the polar jets. Okay. Westerly jet stream is a permanent jet stream. You don't have, so all the jet streams, they are westerly, they are referred to as westerly, because the permanent jet streams, they are referred to as westerly. So you have polar westerly jet stream, subtropical westerly jet stream, because they come from west to east. So these are your permanent jet systems. Both of them will be moving from west to east. Okay. Now, then these jet streams, they also get impacted by the physical barriers. For example, We are not talking about the physical barrier that my building is a 3-story high building. So will it create a barrier for the jet stream? My building is a 20-story building. People say it is the tallest building in my district. So will it impact the jet stream? We are talking about large physical barriers, very, very large physical barriers, such as the Himalayas. So for example, if you take a look at this satellite imagery, now here you will observe the jet stream first. Now, which jet stream do you think this is? This particular jet stream is which jet stream? What do you think? This particular jet stream. Which jet stream? It is a subtropical. What is also the subtropical westerly jet stream? So that subtropical westerly jet stream, here you will observe that it suddenly disappears in this region. Why? Because of the physical barrier imposed by the Himalayas and the Tibetan highlands. Now, you might have a question that, but you have said earlier that they travel in very high altitude. But understand, in these areas where you have a very high physical barrier, so jet streams, they travel because of what? Because of the difference in temperature in the air parcel at a greater altitude. So in a region, let's suppose if you have the very high lofty mountains in the form of Himalayas, let's suppose. So here you can imagine that here you might have the air difference. Here you might have a difference in temperature of the air. But here the air will be significantly uniform. And there will be an obstruction as well due to the height itself. So that is why in these physical barriers, the jet streams disappear. That is why you will observe that this subtropical jet stream, as it encounters, and remember this image carefully. Remember this image carefully, because this will be useful in the immediately next module that we are going to study about the Indian monsoon. It is this particular jet stream, the subtropical jet stream, that is the one which decides when the onset of Indian monsoon is going to happen. That is how important this is for Indian monsoon. So this jet stream continues to move, and then it splits into a northern branch, and then it splits into a southern branch. Right? Now, what do you think will happen when the summer season comes in? When the summer season comes in, will there be a shifting of jet stream? Yes or no? Will this jet stream shift? Yes or no? Good. Now, once we have said that yes, it will shift, then in which direction will it shift? Will it shift to the north? Will it shift to the south? What do you think? In the summer season for the northern hemisphere, I'm talking about. It will shift to the north because all the pressure belts will shift to the north. So basically, the jet stream will also shift to the north. So this jet stream will shift to the north. So what do you think will happen to this southern branch? Do you think this southern branch will start climbing over the Himalayas like Edmund Hillary, and then will cross over the Himalayas ever so slowly? No. This jet stream, the southern branch, during the summer season will start to weaken and eventually die out. Unless and until it dies out, it will still be present significantly over the region of central India and northern part of the Indian plains. And we will study later how this ensures that there is no rainfall in India. As long as this is present over India, you don't have rainfall which is received, especially due to the monsoon. Okay. Now, jet streams end up getting influenced and will in turn influence the weather condition in a region. They will have significant amount of influence on the weather condition of an area. So when we talk about the influence on the weather condition, first of all, these jet streams, because they are movement or they indicate a movement of wind pattern in the upper atmosphere, they are able to carry the low pressure and the high pressure cells along with them, in the sense that they can help carry clouds from one region to another. They can help carry certain disturbances for many of the kilometers, hundreds and thousands of kilometers. They are able to carry certain disturbances. So that is where the jet streams will impact the weather. So let's suppose in this region, you have otherwise a dry condition. But as these jet streams, they move and they encounter a region where there is clouds, and these jet streams come into existence there, these clouds can very easily be carried over. But in general, understand that jet streams do not allow the mixing of air between different latitudes. They do not allow the mixing of air. Okay? Jets do not allow mixing of air between different latitudes. How and why? For example, if I were to give you a cross-sectional representation of jet stream, let's suppose I talk about somewhere 45-degree north. Let's suppose I talk about somewhere 20-degree north. Now, in between them, you have this air or the movement of jet stream. Let's suppose this is a cross-sectional representation of the jet stream. Okay, so this jet stream will be created due to the difference in air temperature in between these areas. That is where these jet streams will come into existence. And also, when you talk about these jet streams, this will have a kind of an air column associated here, right? So the air from this region can never encounter or never have a kind of a sneaking through between these areas and reach here, and vice versa is also not possible. Now you can have a kind of a question that why is it that it is not possible that air can at least move here? So imagine a condition of a traffic jam. I'm sure all of you, in many of the cases, would have created traffic jams. In many of the cases, would have been stuck in traffic jams in your life. So when you have a traffic jam, take that analogy. So suppose you have a traffic light somewhere here. Okay, suppose you have a traffic light somewhere here. Now the jam is created up till this portion, right? Let's suppose the jam is created up till this particular portion and this particular region. Now, if let's suppose you are an individual in a vehicle somewhere here. Let's suppose you are an individual in a vehicle somewhere here. Now, would you be able to move even up till here as long as the jam is there? No, obviously you won't be able to move, right? Why? Because obviously there is a prolonged traffic jam which is there, right? Similarly, unless and until all this wind ends up moving, unless and until this traffic light gets cleared here, this traffic light gets cleared, so then everything will move, then you will also get a chance to move. Similarly, here, as long as the jet stream moves over an area, the air will start acting like a kind of imposing a traffic jam. So that air won't be able to cross over from one region to another, won't allow the crossing over of the air as well. So the air in this portion gets limited into this area itself. The air in this portion gets limited to this area itself. So wherever you have jet streams, the cross circulation of the air is something which is not allowed. So they play a key role in determining the weather because they separate colder air and warmer air. Okay. So there, basically, no mixing of air between different regions. okay, in between different areas. So there is no mixing. So as a consequence, an area might get very hot. An area might get, over a period of time, might get increasingly hot. So when a region gets hot, there is a low pressure created, winds from the surrounding regions come, there's a rise of wind, and it causes rainfall, provides a relief. But imagine in this circumstance here, if you have a jet stream, let's suppose this region starts getting hotter. Now you will have the creation of the low pressure in this area because of getting hotter. But winds from the surrounding area won't be able to come to the rescue here because the jet streams will blockade it. So even if the air rises, let's suppose some individual air becomes rebellious and says that no, we will rise. So even after that, that particular air will be impacted by the jet stream, will get reflected back, and you have the sinking air in this region. So sinking air, does it create heating or does it create cooling? What do you think? Sinking air, does it create heating or cooling? Hmm. Okay. Let me ask this question again. Sinking air, will it get compressed? Will it get expanded? It will get compressed. Compression creates heating or cooling. Good. Compression creates heating. So that is where, as the air gets reflected back by these jet streams, it will get further heated up. This will further intensify or will further heat up this region. It will then get heated up more. But as long as the jet stream prevails in that area, there will not be any change in temperature here, or there will not be any relief here. Now, here you might have an immediate question that if there is a low pressure, why will the jet stream exist in that region? Why can't the jet stream simply move over that area? Because the jet stream is not a localized phenomena. It is not that the jet stream here in Delhi is very nice, the jet stream over Chandigarh is very crooked and wicked, jet stream over the region of Lucknow is again well behaved. Jet streams, they exist for thousands of kilometers. So let's imagine that of a river. When you have a river movement, let's suppose, if there is some disturbance here, does not mean the river will change its entire course like this. The river will continue to flow over this place. So, like that, similarly, these jet streams are a continuous phenomena. So, in a region, let's suppose there is incredible heating, that region will continue to suffer as long as in the entire portion of thousands of kilometers, that jet stream is a reality. This will continue to get heated. Okay, so this creates prolonged heat waves. This ends up creating prolonged heat waves. Because it will not allow any kind of relief to happen. And again, understand this. This is something that what we also refer to as a heat dome. In the case of Canada and Europe, this is the reason why the region of Canada and Europe have been suffering from incredible amount of heat waves for the past 5 years on an average. So when you have these jet streams, so even if this region gets heated up, the air, even now, the air from this region cannot come in. The air from this region cannot come into the rescue, because ideally, if you have a low pressure in an area, air rushes in, rises up, forms the clouds provide rainfall, and everybody goes happily to sleep, right? But in this region, when you have the jet stream, so even if the air rises up, it cannot go any further. It will be further pushed down, and that will further continue to heat up, and that creates what we refer to as the heat wave phenomena, where the temperature keeps on rising significantly and keeps on increasing quite significantly. So this is the reason for heat waves in the region of Canada, in the region of Europe, and last year, even in the case of northern portion of India. So this is over Canada and, or rather, Canadian and European heat waves or heat domes. This is also the reason why, as the polar jet was very persistent, even in the region of Siberia, which generally experiences very low temperature, in the region of Siberia, you experienced a temperature of around 45 degree plus. Okay, that is the aspect of this jet stream. Now, this is a question, the PYQ guys. Where is Harpreet, who was asking for PYQs? Okay, so now we have the PYQ. So take a look at this question and let us solve this particular question. So consider the following statements. So jet streams occur in the northern hemisphere only. Only some cyclones develop an eye. The temperature in the eye of the cyclone is nearly 10 degrees Celsius, lesser than the surroundings. Think about it. Good, Shiva. Manikandan, Garvit, Pula, Vivek. Good. Ananya, Akshita. Good. So good. Majority of you have given the correct answer. So jet streams occur in northern hemisphere only? Absolutely not. They will be occurring even in the case of the southern hemisphere. Then only some cyclones develop an eye. That is correct. We have seen that tropical cyclones will develop an eye, temperate cyclones. They sometimes will develop, sometimes won't develop an eye. And the temperature inside the eye of the cyclone is nearly 10 degrees Celsius, lesser than the surrounding, which is not the case. The temperature in the eye of the cyclone is going to be higher. How much higher? It varies. So here, understand, this is another trick that UPSC has got up its armor. Yesterday, we had seen with the help of the two PYQs that how UPSC will play a trick by just replacing one word out there, and you will get confused in the entirety. Here, this is another trick that UPSC plays. That is to indulge you in the data pointers. Okay, so when you get indulged in those data pointers, when you get trapped in those data pointers, your entire attention is towards the data pointers itself. What do I mean by that? So for example, here the jet stream, the question could simply have been that the temperature in the eye of the cyclone is lesser than the surrounding. It would have been easier for you to catch the mistake in this. But the moment UPSC mentions 10 degrees C lesser, that is where you get an idea that, okay, it might not be 10 degrees Celsius. Is it 5 degrees Celsius? Is it 15 degrees Celsius? Is it 8 degrees Celsius? Maybe my friends would have studied it. The book that I have studied, that did not mention it. So there is a kind of a feeling of betrayal. But this is the entire purpose of using that data. Once you use that data, you tend to believe that statement. If I tell you the rate of literacy in India has gone up, you might believe me, you might not believe me. But if I tell you the rate of literacy in India has gone up by 67%, you will definitely believe me that he is indicating some data. So it might not be 67, it might be 65 or 70. So never get misled by this another trick. This is something that UPSC will use at its arsenal, even in the case of the other subjects in the portion of current affairs. So please pay significant amount of attention in this. Okay, so that is all that I can tell you in the case of the trappings of UPSC. Horse latitudes have jet streams, yes. I region is calm, yes. And Ananya, I had BA honors geography, but today is the first time I understood jet streams. Okay. So, see, once you keep it simple, you will be able to understand it. In Google, it shows correct. It is correct. What is correct in Google? That the eye is colder? No. Extra tropical cyclones will sometimes not have an eye. Okay? Extra tropical cyclones sometimes will not have an eye. When we experience jet streams over India, their direction is west to east. At the same time, if we experience trade winds moving over India, their direction will be east to west. So, what will happen to the direction after the collision of the jet streams and the trade winds? Okay. So, here, understand, trade winds are moving at the surface, jet streams are moving at the upper atmosphere. Will there be a collision which will happen? No. So, no collision happens. Okay. As simple as that. So, now we come over to one of the most complex topics out there in the entirety of climatology, where the scientists have taken many years to understand that. And this is where now we have some fair amount of understanding, but still more researches are being carried out. That is India's climate, and that is what we study, and we will study here about the monsoon phenomena. More complex, yes. So here you will be required to put the application of all the various aspects that you have covered till now in climatology. So when we talk about the various aspects of climatology and even certain aspects of geomorphology, all of them are at play. And trust me, even as late as November last year, there was a fresh research paper which was filed by the Research Institute in Pune, which talks about a correlation which has been established between the region of the North Atlantic closer to the poles and the amount of rainfall received in India. So that is how complicated it is. And how do we predict the monsoon is basically with the help of supercomputers. I hope we are aware of that we have certain supercomputers in which we feed the data, and we feed the data and all the details we feed, that what is the temperature in northern Pacific, central Pacific, southern Pacific, what is the temperature in eastern coast of India, western coast of India, what is the temperature in Atlantic, etc. So a few years back, almost a decade back, what happened was that while feeding the data, one decimal pointer, that is the third decimal pointer, eventually was incorrectly fed, and the output which was generated by the supercomputer that varied to indicate that it will be a drought year, whereas it was a surplus rainfall year. So imagine that in one place of the planet, even if the temperature varies by 0.01 degree or zero point 0.02 degrees Celsius, it can have that much amount of difference across the Indian monsoon phenomena. So that is how the Indian monsoonal phenomena is truly unique, something that you don't experience anywhere else across the planet. Monsoon is what? Monsoon is derived from the Arabic term that is mausim, which tells about the seasonal reversal of winds. That is as simple. So, monsoon talks about the seasonal reversal of wind direction. Now, you will observe that this seasonal reversal of wind direction, in true sense, is observed only over India. It is not to be observed in true sense anywhere else. There is some reversal, partial reversal, etc., but in real sense, the true reversal will be observed only over the country. Now, here again, what we will do is we will try to use a kind of a different approach to understanding the monsoon. And in general, in the books that you study, monsoon is talked about with the aspect that rainfall happens. Then this rainfall, when it happens, this is also what we call as the onset. Then eventually rainfall stops, what we call as retreat. Here, what we are going to do is, first of all, we are going to understand all the various different factors, all the various different factors which influence the monsoon, all of them. We will understand them one by one. Then we will have the interconnection between all of them. We will be weaving a story around them. and we will form an entire dynamic mechanism around the behavior of the monsoon. Okay, so what I would suggest to you is, please follow this approach at least for the initial stages to clear your concepts. After that, you are free to explore the books of NCRT, GC Law, whichever book that Majid Hussain, whichever book that you want to follow, you are free to do so. But I would always suggest to you that follow the concepts here. Once you are able to understand the concepts, you will never forget those particular concepts. Okay. Despite having higher volume, why warmer air on land has low pressure? Because the weight imposed is not very high. Okay, weight imposed is not very high, and you have the rising air in general. And the rising air is up till only the level of tropopause, right? So when you compare the pressure closer to the tropopause, that is where the pressure difference is very apparent. Now, this is a region which is one of the favorite areas of UPSC. Earlier, UPSC would necessarily ask a question from monsoon every time in the mains or the prelims examination. And if you take a look at the papers around 20 years back, now there the pattern would be very different, where a candidate would be required to write very long answer, 600 word, 500 word answer, 300 word answer. So the mechanism of monsoon would necessarily be asked. But why is monsoon important for us? Monsoon for us is not only about rainfall. For us in India, monsoon is life. Monsoon is something for which our farmers, they wait for eagerly. They depend on it eagerly. They pray for those monsoonal rains. In many different parts of the country that you go, you have their own individual cultural traditions which have been followed for hundreds of years or many decades altogether, where they have a separate kind of worship to pray for rain, be it in Karnataka, be it in Tamil Nadu, be it in Kerala, be it in Assam, be it in parts of Rajasthan. They do pray for rain because it is important. In India, almost two-thirds of the rainfall that we receive, or in fact, even more than that. So close to around 70% of the rainfall, 70 to sometimes 80% of the rainfall that we receive in India is received during the monsoonal months. Now, if the monsoons they fail, we have large-scale crop losses. The farmers, their income is lost. Many of them, sadly, due to the economic crises, they have been forced to commit suicides in the past decades, if you consider that. Many of them, they wait for these rains eagerly, but suddenly there is surplus amount of rain, creating floods, leading to the crop losses. We have seen the disasters unfold in Uttarakhand. We have seen the disasters unfold in Himachal Pradesh. That is monsoon for us. So while it can be provider for new ray of hope and life for us Indians, it is also something which can cause immense amount of disaster. The rainfall that you receive during the monsoon, that is something which keeps the entire nature happy through the year. The rainfall, it fills up various different areas with water. Drinking water is provided. Now, drier regions such as eastern part of Maharashtra, the Vidarbha region, the region of Telangana, they are completely dependent on monsoon itself. So, monsoon means life. So, that is what we'll take a look at this. Before that, we take a break, and after break, we carry on. Okay. So we take a break and we come back by 7, I think, and then we will carry on. Okay. Kamal, it's 7:02. Yes, my dear friend, it's 7:02. So, a confirmation about the audio, please. The audio is clear. Good. So, this particular portion is particularly relevant both for your prelims as well as mains examination. So, in the prelims, you do get questions, very frequent questions from this area. So, there you will have a general aspect of the concept. So, factors influencing Indian climate, influencing features of Indian monsoon, then distribution of rainfall. By the way, guys, do we have an idea or a clue where we have Mascarene Islands? Yesterday we talked about the Mascarene Islands. Do we have a clue where do we have Mascarene Islands? It is in southwestern portion of Indian Ocean. Peru, no. Southwestern portion of Indian Ocean. Besides Africa, yes. Good. Western disturbances. Now, ideally, India's climate is a part of Indian geography, but then because we are talking about the portion of climatology, and I have understood the amount of retention capacity and the revision capacity that many of us have. So it is always advisable to refer to this while we are dealing with climatology, so that once this portion is clear, this area of Indian geography in general, which is a very important portion of Indian geography, that also will be taken up along with that. Now, for the mains, you will also find questions ranging from the portion of Western disturbances, what they are, the portion of factors influencing Indian climate. And you get a kind of a supplementary question along with that, that also describe about or discuss about the variation in Indian rainfall or the distribution of Indian rainfall. So that kind of a variation in question is something that you also experience. Okay. Now, before entering into the area where we study about the factors influencing Indian climate, here, first of all, a basic about monsoons. So when we say monsoon, as we already have talked about it, so monsoon refers to the seasonal reversal of wind. Seasonal reversal of wind. When we have the seasonal reversal, so if a wind direction in a region is like this, if let's suppose it gets reverted into this direction after a particular or during a particular time of the year, that is the reversal of wind direction. So that condition is what is referred to as monsoons. Now, here, when we talk about these monsoons, it is something which we Indians have known, that we have a season of rainfall, and we have known this for a long period of time. But it was the Arab travelers who basically came upon this and chanced upon this many hundreds of years back. And that is when they understood that while coming to India, you have a particular season from the month of June to August and almost up till September, where the winds, they are having a direction towards the Indian coastline, towards the western coast of India. And then that is the time that they would utilize to come laden with their ships or carry their ships towards India. And then they would know that there is a seasonal reversal, and in the month of after that, that is the month of November, December, etc., the wind direction would be exactly the opposite. And that is the time they would utilize to move away from India and carry out their trade. So that is where the term mausim earlier was used. Mausim. So mausim here refers to seasons. Okay. And slowly it has taken the name of monsoon. Now, you have the various aspects of monsoon. We'll take a look at that in a few moments. But before that, let us analyze the factors which influence the climatic conditions in India. Now, India is a region where you experience a variety of various different types of climatic conditions. You experience or you come across a various different types of climatic conditions across different parts of the country. Now, in our country, when you move from north to south, when you move from east to west, not only do you experience a variation from very cold conditions in the northern part to very warm conditions in the southern part, very heavy rainfall in the eastern part to deserts in the western part. Think about a climatic condition, imagine about a climatic condition it is to be found in India. The diversity of Indian subcontinent is something that we will be discussing at a later stage when we initiate the full-fledged discussion about Indian geography, that why it is referred to as a subcontinent and why it is a subcontinent in the truest of the terms. But that is something very unique to India. And that is the beauty of this particular landscape. So what are the factors which influence the conditions? So first of all, the latitudinal extent. Now, when we talk about the latitudinal extent, so here when we talk about it, so here you have to understand that, and I am sure all of us know, India lies entirely in the northern hemisphere, and India is completely above the region of equator. Tropic of Cancer passes through the central part of the country. It almost appears to divide the country into two parts, almost. So the region to the north of the Tropic of Cancer will experience a kind of a subtropical climatic condition, whereas the region to the south will experience tropical, and eventually, as you keep on moving to the southern part of the country, there is a variation in the climatic conditions. So the climatic variations between the north and the southern part of the country is primarily because of the latitudinal extent that we have. And it is here, had India lied to the south, had India been on the region of or in the area of equator, our climatic conditions would have been very different. Had we been situated completely to the north of Tropic of Cancer, our conditions, our climatic conditions would have been very, very different. So our climatic conditions, they are influenced by the latitudinal extent. Then the Himalayan mountains. Now, Himalayas, they do influence and impact our lives in many different ways, more than many ways. Traditionally, if you talk about it, not only are these the sources of these giant rivers which originate from the Himalayas, which provide endless supply of water, but also when we talk about the Himalayan mountain region and the Himalayan region and landscape in general, you have to understand that they also provide a kind of a natural defense, a natural frontier in the north. They protect us from the cold winds coming from the region of the north. And that is where they provide a kind of a shield for us. Now, we have seen in the case of blizzard in United States that how when you have the cold local winds in the form of blizzard, they can impact the almost the entirety of the United States, because in the region of United States and North America, you don't have an east to west mountain system. So they do protect us from the cold winds from the north. Also, these act as a kind of an orographic barrier, and that orographic barrier provides rainfall. So the moist winds coming from the region of Arabian Sea and Bay of Bengal, they hit the Himalayas, they cause rainfall. Even for the natural defense against enemies, Himalayas have always provided a kind of a natural frontier, natural boundary for us. If you take the case, be it as early as the Huns or the Mongols, they have never been able to cross the Himalayas. So the role of Himalayas in our life has been truly enriching and much greater. But when we talk about the climate, it is very substantial. So they act as an effective climate divide. They protect the subcontinent from the cold northern winds. They act as a barrier which stops the moist winds coming from the nearby water bodies and cause significant orographic rainfall. Okay, so create an orographic barrier and cause significant amount of rainfall. So imagine if the Himalayas would not have been there, then not only would the northern part of India would be very cold, further cold, it would have been exposed to very cold winds coming from the higher latitudes, but also there would be nothing stopping these moist winds and there will be lesser rainfall. Now, after today's session, I want you to open up the atlas and take a look to the west of India at the similar latitude. You will find that at the similar latitude, you will find the presence of desert areas, be it in the region of Pakistan, be it in the region of, even when you talk about Iran, be it in the region of West Asia, be it in the region of Africa. At the similar latitudes, you have the creation of the high pressure and you have the creation of a desert. But it is because of the Himalayas that the northern part of India is not a desert. Okay, so Himalayas have a significant role to play. Then we have the relief features. Relief features, in the sense, here they talk about the physical barriers. Physical barriers which have been imposed, which have been created by the plateaus, the hill systems that we have. Now, the relief features that we experience, they create what kind of rainfall? Orographic rainfall. What is orographic rainfall? So whenever you have any obstruction in the form of a mountain, or let's suppose even a plateau, they will push the winds upwards. They will create the vertical rise of the winds, due to which the winds get very cold. They start to condense. They form very dense clouds and they will cause rainfall. Meanwhile, on the other side of the mountain, will this region receive rainfall or will this region be dry? What do you think? It will be dry. This is what is the leeward side of the mountain and the rain shadow zone. Perfect. Very good. Leeward side and the rain shadow zone. Okay, so that will be very dry. Okay, overall, if you take a look at the stretch of the various different physical divides that and the various different physical features that we have. So if you talk about the region of the Himalayas, for example, let's suppose if you consider the ranges of the Himalayas, they form a barrier, they form a consistent system here significantly. You have the ranges of the Himalayas here in this area. So there is a barrier here as well. You have the ranges here as well. Now, what they do is they, in a way, stop the moist winds. They act as a barrier for the moisture bearing winds. Now, That is the reason why when the moist winds from the nearby Arabian Sea, when they hit the region of the Western Ghats, now this portion of the Western Ghats, they receive very heavy amount of rainfall. They receive very heavy amount of rainfall. Now here you will find that you have the prolonged stretch of Vindhyas and Satpuras. They provide a kind of a passage for the wind. The wind can reach to the central portion of India, cause significant amount of rainfall here. Otherwise, this area is drier. This is the dry region in general. Why? Because it is on the leeward side, the rain shadow zone. This area is also dry, the Thar Desert. Why? Because of the alignment of the Aravallis, the orientation of the Aravallis. Because the shape and the orientation of the Aravallis is such that the moist winds coming from the region of Arabian Sea, they move almost parallel to the Aravallis. So there is nothing stopping them at all. At max, there will be some rainfall observed in the southern part of Rajasthan and portions of Gujarat, the area around Mount Abu, for example. Then, even when we talk about the moist winds coming from the region of, let's say, Bay of Bengal, they will end up hitting the region of the Aravallis. So, the region of Thar Desert is in the leeward side. So, that is why the area of eastern and southern Rajasthan will receive rainfall, but western Rajasthan continues to be very, very dry. Now, if you observe the mountain stretches and the hilly stretches in the northeast, now here you observe that the hills make up a kind of a funnel shape. So, funnel shape basically, what it actually translates on the ground is that if you have the moist winds coming from this area, when they hit the Himalayas, some portion will come here, some portion will cause rainfall here. The portion which enters the northeast, whatever amount of moisture that it has, whatever amount of moisture that it carries, it will immediately be dropped here in this region. That is why the northeastern region, because the moist winds get entrapped there, that is why the northeast region also is a region of very heavy, very intense rainfall activity, which is observed. So that is how the presence of these orographic features or the relief features, they will end up influencing the amount of rainfall, the rainfall distribution in general that is experienced. So, for example, the windward side of Western Ghats and Assam receive high rainfall, whereas the southern plateau remains dry. So, it is the aspect of rain shadow zone and the leeward side as well. Now, India is a landmass which is surrounded by water bodies from three sides. That is why the entire stretch here, that is referred to as a peninsula. A peninsula is a landmass which is surrounded by water body from three sides. Now, being surrounded by water bodies from three sides means what? It basically means that you have multiple factors here. Long coastline. Now, coastal areas experience moderate amount of temperature throughout the year. Then also during the summer months, we know that there's a differential heating of land and water every time. So during the summer months, the land gets very, very hot. Nearby water body is comparatively colder. We know that. So when you have the summer months, due to intense heating of the landmass, you have a low pressure created over the landmass, a significant low pressure. Whereas the water body, because we are surrounded by a water body will experience a comparatively cooler temperature. So a comparative high pressure will develop here. Comparatively, right? So that will fuel the movement of winds here. So that is where During the summer season, during summers, land gets extremely heated. Okay. Water is comparatively cooler. So you have a comparative pressure gradient which is created. Pressure gradient. So in general, during these months of the summer season, what will be the direction of the wind movement? Wind is onshore. Onshore winds are rich in moisture. And winds which are rich in moisture cause rainfall. Okay, they end up causing significant amount of rainfall in the process. So that is what you experience in this situation, that they end up creating and causing sufficient amount of rainfall in the process. So early explanation of monsoon, which was provided few centuries back when we did not have enough information, so you had the basic explanation which was provided for the monsoon, that see, the land gets heated, that land experiences low pressure, and then the nearby water bodies, they are comparatively cooler, so that is why winds will come from sea to the land, and that wind will be rich and moisture laden, and hence it will cause rainfall. It was the simplest and the earliest form of explanation for the monsoon rainfall. It was later on understood that these wind patterns, they are impacted by many things. Temperature and events in the Pacific can end up influencing the impact over the Indian region. The heating of the Tibetan highlands can end up impacting the temperature over and the amount of rainfall received in India. So that is where slowly and steadily we get to know more about the impact of the monsoons and the cause of the monsoons. Then you have a variation in temperature experienced different parts of the country, and that is primarily dominated by the altitude, or differentiated and determined by the altitude. So when we talk about the altitudinal variation, so here different places have different amount of height, isn't it? The height is different. So when the height is different, so that means with altitude, the temperature tends to reduce significantly, isn't it? So you will have the places which are situated at greater altitude, they will always experience a kind of a lower temperature range, or lower temperature in general. Whereas the places closer to the sea level in the plains, they will experience a higher temperature. So, for example, take the case of Agra and Darjeeling. Now, even though both of them are situated at the similar latitude, you will find that because the elevation of Darjeeling is higher, Agra is closer to the sea level. So that is why the temperature in Darjeeling is much lower as compared to what you experience in Agra. So that is where the altitudinal variation also creates a difference in the temperature which is experienced. Now, after this, we come to the portion of the factors influencing the Indian monsoon. So, Indian monsoon is impacted by many different factors overall. So, first is the differential heating and cooling of the land. That is the rate at which the land gets heated and the water gets heated. So, that is different. So, that is basically going to create a pressure difference. So, this creates a pressure difference. A pressure difference. Okay, that will induce a kind of a movement. Then the shift of the ITCZ, the ITCZ also ends up shifting. With the variation in the seasons, we do know that there is a shift of the pressure belts, and ITCZ being dominated or determined by the presence of the low pressure, the thermal low pressure. So the region which gets very heated up, the ITCZ also shifts during the summer months. As if you talk about the present conditions, now the ITCZ has been present for the past couple of months significantly in the northern portion of India. ITCZ can extend into the region of the northern plains of India. As the during the month of April and May, the temperature keeps on rising, the ITCZ shifts north as well. Then here we have the subtropical westerly jet stream. It has got a significant influence to play and a significant role to play. The subtropical westerly jet stream is something that we studied just now, right? Heating of Tibetan plateau and the creation and generation of the tropical easterly jet stream. Okay, so basically, when we talk about the tropical easterly jet stream, that is also created because of the heating of the Tibetan plateau that strengthens the Indian monsoon. It can provide excessive rainfall during certain years. So that is the role which is played. We will talk about all of this. I have provided in the PPT and the slide the written text as well, so that you don't need to create copious notes out of it. So as of now, I just want you to pay maximum amount of attention that you can to the entire aspect. Then you have the mascarene high. This is basically the high pressure created around mascarene islands. These are the drivers of the monsoon winds, right? So these are the areas where, or this is the region from where the monsoon winds, they are driven off or they originate. Then you have the impact of enzo cycles, that is El Nino, La Nina circulation, and also the impact of IOD. So first of all, let us understand these factors in detail, and then we will be able to get at the entire mechanism driving the Indian monsoon. So first of all, we come to the portion of heating of land and water. So let's have the equator first, a rough equator. Now here, during the summer months, that is in the region, in the months of later part of March itself, in the portion of May, and also in the months of April, you will observe that the land gets significantly heated up. So when the land gets heated up, you have the creation of low pressure. This gets heated up at a much greater rate. When we talk about land and water, always land will get heated at a much exaggerated rate. So that is where it gets heated quite disproportionately. So when it gets heated up, that creates a thermal low pressure. Nearby water body is comparatively cooler. So here you have a comparative high pressure. Comparative. Always remember the term comparative. So that is where you will have the winds which originate from the water body or generally driven from the water body to the land areas, the onshore winds. These will bring moisture. So during the summer season, land becomes extraordinarily hot. You would have experienced that in majority of the parts of the northern part of the country, we start experiencing the temperature close to around maybe 45 to even sometimes even 50 degrees Celsius. So the temperature experienced is extraordinarily high. So the land becomes extraordinarily hot. The nearby water bodies are cooler in comparison. As a consequence of this, the cooler moisture laden winds from these water bodies, they hit the landmass, causing sufficient amount of rainfall. Okay, so that is when they will hit the landmass and they will cause high amount of rainfall because the winds are laden with high amount of moisture. Then we have the shift of the ITCZ. ITCZ is what? ITCZ is the thermal low pressure zone. Thermal low pressure. Now recall the tricellular model that you had seen. Now this ITCZ, it shifts north and south in between the various seasons. It will shift to the area where you have significant amount of heating which is created. Now, during the summer months, when the temperature in the entirety of the area, right from the Sahara Desert to the Arabian Peninsula, to even when you talk about, let's say, the Indian subcontinent, here also, the temperatures oftentimes they exceed around 45, 50 and 45, 48 degrees Celsius. Easily they are above 40 degrees Celsius. So the low pressure, the thermal low pressure shifts over to India. Now, that is the general movement. So the ITCZ shifts north during the summer, and again during the winter, when it is the summer in the southern hemisphere, the ITCZ then has its movement or its march to the south. So again during the winter, observe it comes slightly to the south. But during the summer, that is when it ends up moving over the northern part of the country. And this is the driver or the attractor of the winds. How? Let us understand that. I will show you the satellite image of the wind pattern which is experienced as well, so that you get a better clarity about that. So here, let's suppose you talk about the equator here. Now, during the summer season, these areas, they get extraordinarily heated up. All these areas, Thar Desert, Northern Plains, they get very, very heated up. Now, the ITCZ, over a period of time, it reaches there. But that reaching or that movement, it won't be a sudden movement. That is a slow movement. So you will observe that slowly it moves. So how does the movement happen? So initially the ITCZ from the month of March, in the month of March, ITCZ will be somewhere here. Then in the month of April, ITCZ will be somewhere here. In the month of later part of April and May, ITCZ will be here. Then in the month of June, July, and some parts of August, ITCZ will end up reaching here in the month of June, July. Okay. Now, once the ITCZ, let's suppose, reaches this particular portion. Now, as per the tricellular model of circulation, ITCZ is the attractor of winds. Isn't it? As per the tricellular model of circulation, you have the ITCZ, and from there, from both the subtropical high pressure belt, winds they come in, they are attracted towards the ITCZ, they rise up, they form clouds, they will cause rainfall. Right? This is something that we have studied significantly and we are comfortable with. Now, when the ITCZ is shifted here, now obviously this northern subtropical high pressure belt would also have shifted somewhere here in the north. So those winds won't be able to reach the ITCZ because of obstruction provided by the Himalayas. But nonetheless, the ITCZ will continue to attract winds from the southern part of the subtropical high pressure belt. The southern part of subtropical high pressure belt is created around the region of the Mascarene Islands. Remember, in that module of atmospheric circulation, we had seen that you have the pressure zones, pressure cells which are created, the high pressure and low pressure cells. So this is where you have the high pressure, and that is high pressure near Mascarene Islands. The high pressure which is created near Mascarene Islands. Now here, when you have the movement of the wind from this region, earlier the wind will be deviating to the left. The winds Now the winds have only one destination in this case. The winds in this case have a destination that is what? That is basically the ITCZ, isn't it? So the winds have a movement towards ITCZ. That is what they are trying to reach at. But the winds will be deviated to the left owing to the Coriolis force. Okay. This STHP here stands for the subtropical high pressure. Subtropical high pressure. So here, the winds, after they cross the equator, what do you think will happen? Around the equator, anyways, you won't observe any kind of significant Coriolis effect or any kind of bending. But as soon as they cross the equator, these winds, they will bend to the right due to the Coriolis force. They will start bending to the right and they will start approaching here. The winds approach here. The winds will be crossing the region even into the area of the Bay of Bengal. They will hit the Arakan Yoma, Pegu Yoma, Tanasarim mountain ranges, and then they will be diverted here. Isn't it? Now their destination is what? ITCZ. Now, what is the direction of winds in general here? What is the direction of winds? We have discussed that the winds are named based upon their direction. The winds, can we say they are coming from southwest direction? Isn't it? We can say that they are coming from the southwest direction. So that is why these are the winds which are referred to as the southwest monsoonal winds. And this has happened when the ITCZ is advancing over the Indian subcontinent. So slowly and steadily, these winds will be advancing over the portion of India. So that is why this is referred to as the southwest monsoon. Okay, so these are also what are referred to as advancing monsoons. Okay, so the winds will bend owing to the Coriolis force. That is why they will start bending to the right. Their ultimate destination is the ITCZ. That is their ultimate destination. And this ITCZ, by the way, I'll first of all I'll show you the satellite image here. Observe this satellite image for the wind direction. Observe the satellite image here. Observe how the winds, they are originating from the region of southern hemisphere. They are moving here. They are crossing the equator. They are bending to the right. Right. And observe they are in which direction? They are in the direction of southwest to northeast. So that is what you will have as the wind movement in general. Okay, so that is why it is southwest monsoon. Okay, so that is the case of the southwest monsoon. Now from here, I want to drive another concept from this particular portion. So the concept of advancing monsoon. So it is not as if suddenly the ITCZ has reached in the northern part. In the month of April, late part of April, ITCZ will lie somewhere here. Now, ITCZ, when it lies over this region, what will be the wind? The wind till that point of time will have a motion like this. Right? Now, this is the low pressure. This is the ITCZ. This is the low pressure. So, winds are attracted towards this low pressure. Now, let us understand a particular concept here. So, when we say that the ITCZ is present in this position, can we also say, or can we also deduce that in these areas around the region of Bay of Bengal, around the region of Arabian Sea, can we say that in these areas there will be a pre-existing low pressure zone which will be created? Can we come at that conclusion? Yes? Maybe. Okay. Maybe also works for me. So we can say ITCZ is a region of low pressure. So that is where you will have a pre-existing low pressure. And pre-existing low pressure belt over the water body during the summer months or during any season, that can create a condition for which atmospheric phenomena? What do you think? When you have a low pressure over water body, which atmospheric phenomena? Good, a cyclone. So that is why in the part of late April, when the heating has already begun in the northern hemisphere, that is a season of cyclone. Either in Arabian Sea or in Bay of Bengal. Okay? Then, in the month of May again, when we talk about the month of May, the ITCZ would move further. Let's suppose we consider that in the month of April. Let's suppose we consider that in the month of April, this is the extent of ITCZ. In the month of May, this is the extent of ITCZ. Right? So again, when we talk about the month of May, this is where, again, what will happen? A tropical cyclone will develop. Isn't it? If you have sufficient heating of the water body, that low pressure is sufficient and significant to create that cyclone, isn't it? Now, after that, furthermore, in the month of June also sometimes, you will observe that the ITCZ, it gets distorted here. It remains like this. So there also, early June, sometimes, very rarely. Okay, so early June, that is very rare phenomena, by the way. This year we did experience this. Biparjoy was created in the early months or early time or the early days of June, if you recall. Now, once the ITCZ has reached here in the month of July, August, it stays there. September is when it starts withdrawing. So in the month of July and July and August up till September, when ITCZ is over land area, will you experience that low pressure development of the water body? No. That is why in the month of July, August, late part of June itself, late part of June, July, August, there you don't expect or you don't experience a tropical cyclone to get created. Okay, so that is why you don't have the cyclonic seasons in these months. Now, from the month of September onwards, as the September is when you have equinoxes. After September, you have the southward movement of the sun, the position of the sun. So, in the month of October, sun will be slightly in the southward position. So, that is when, from the month of September onwards, the ITCZ begins its retreat. So, October will again, when it will be retreating. Then, when we talk about, let's say, the month of November, as the ITCZ is withdrawing. So let's suppose in the month of June or month of July, this is the position. So all the winds will be directed towards this particular ITCZ. Now, from the month of September onwards, as this starts to retreat, in the month of late October, November. November is when the ITCZ will come back here. Late November is where it will be here. December is when the ITCZ will be here. So that again will create the condition of low pressure. So that is where you will also experience this in the month of November and December. Is that understood? That which are the seasons of cyclone experienced in India. Now, many of you had a question earlier about the movement of the cyclones. Why is it that the cyclones are moving in the northern part? Why is it that they move in northern direction? So here again, the answer lies to the position of the ITCZ. Let's suppose there is significant heating of the water and the land areas as well during the summer months. In certain cases, for example, when you had the cyclone Taute, which developed over the region of Arabian Sea, the Arabian Sea waters had warmed to a temperature of 32, 33 degrees Celsius. That is how hot it had gotten. So it can get very, very hot over a period of time. So here, if you observe this, let's suppose you have the ITCZ in this region. Let's suppose. Let's suppose there is a heating which has occurred, and that heating has created a tropical cyclone in this region. Let's suppose. Now, in this region, if a tropical cyclone is created, now it will be aided by the wind motion. The movement of that cyclone will be aided by the wind motion. Wind motion is towards where? Towards the ITCZ. So generally the wind will try to carry it towards the ITCZ, but there will be the Coriolis impact on the wind as well. So the wind will have a kind of a movement like this. So which areas will it hit? It will hit the coastline of Gujarat and Maharashtra. That is why you will very rarely observe that a cyclone has hit the western coast of Karnataka. Never. Generally, it will hit the coastline of Maharashtra. The Arabian Sea cyclones will hit the coastline of Maharashtra and Gujarat. Now, imagine similarly, if you have a cyclonic disturbance which develops here. Right? Now, that cyclonic disturbance will end up moving towards the ITCZ. It will curve as well. So that is where it will hit the region of Odisha, Bengal, and the region of Bangladesh. So cyclones which generally occur in the months of April and May in Bay of Bengal, they will end up hitting the northern portion of the coastline, that is Odisha, West Bengal, and portions of Bangladesh. Cyclones which occur when the ITCZ is here in the month of December, they will have an impact over the region of Tamil Nadu, Andhra coastline, and overall, because the impact is created, they will also influence some parts of Kerala coastline. Okay, so that is why you have the movement of the cyclones. Okay, why is it that the ITCZ line is curved? Because the land is much more hotter. The isotherm. Observe the isotherm map, you will understand. So the ITCZ is a zone indicating lowest pressure in the tropical region. This is the thermal low pressure. Thermal low pressure. Okay. Now, it is in this zone that winds from both the tropics, they end up converging. ITCZ moves to the north and the south with the apparent movement of the sun, with the heating of the land, cooling of the land. Now, during the monsoon months, which follow a prolonged summer season, always monsoons will follow a prolonged summer season. If the summer has not been very hot, the monsoon and its impact will also be slightly weakened because that intensity of low pressure will not be high enough. So during those months, the ITCZ passes through the northern portion of India. So this attracts winds all the way from the southern subtropical high pressure belt. Now the winds which are coming, they would have traveled thousands of kilometers over the water body. They would have covered thousands of kilometers over the water body. So they would be very, very significantly laden with moisture. So that is when you have very moisture laden winds. Moisture laden winds. And this creates rainfall. And that is why southwest monsoon brings copious amount of rainfall. By the way, if I ask you which are these winds? When we talk about the classification of these winds, what can these winds be? Good. Very good. These are your trade winds. The trade winds which have simply crossed over into the portion of the northern hemisphere. Okay, so these are basically the trade winds that you have. Okay, now then after that, why did they bend leftwards in the region of Bay of Bengal? Because they are attracted towards the ITCZ. The winds, they will only know high pressure and low pressure. So that is why they are attracted towards the ITCZ. All of them, they are attracted towards the ITCZ. Okay. Now, then we come to why not in October? Because in October you don't have the low pressure system over the water body, and October is cooler, so that is why no cyclone in October. Why not in August? Someone will ask. So before that itself, because in August you don't have the low pressure system over the water body. August is also comparatively cooler than the summer months. That is why no cyclone in the month of August as well. Whenever you have the movement or the presence of ITCZ, that is when the ITCZ over the water body, that creates a conducive condition for the low pressure that will end up creating a kind of a cyclonic circulation. Okay. Now, then comes the role of the subtropical westerly jet stream. The subtropical westerly jet stream. So that is something which also ends up traveling and shifting with the pressure belts. It shifts with the pressure belts. With the pressure belts. Right? So that means during the summer months, shifts north. In winter months, shifts south. Okay. Now, as we had seen earlier, if I can take you back a few slides here, as we had seen earlier in this case, that the pressure, the subtropical westerly jet stream, it gets bifurcated into the northern and southern branch. Why? Because of the obstruction in the form of Himalayas. So let's suppose you consider the Himalayan mountain range. Let's suppose you consider the Himalayan mountain range. Now, if the jet streams are moving at this level, they cannot simply crisscross or climb over the region of the mountains, can they? You cannot expect them to climb over the mountains. So that is why they get divided into a distinct southern branch and a distinct northern branch. Now, this is your jet stream. If you can imagine, this is your jet stream of this particular portion. Now, if this jet stream moves north or moves south, now imagine if this jet stream moves south. Can we say that the southern branch will get stronger? Can we say that the southern branch will get stronger if the jet stream moves south? Yes, right? Because as it moves to the south, immediately it will start supplying more winds here. Then when it moves to the north, The entire jet stream, when it moves to the north, the northern branch will get stronger, southern branch gets weaker. So let's apply that same logic. So here we have the presence, first of all, of equator. Let us draw the equator here. So during the winter months, in general, when we talk about the subtropical westerly jet stream, so during the winter months, they end up moving to the south. Now you have a northern branch which ends up meeting here again, and you have a very distinct southern branch. Now during the winter, the southern branch of the jet stream will be very, very strong, because the entire jet stream formation, the entirety of this movement will keep on supplying to the southern branch. That is where they are situated. This is your winter. Now, as the summer comes in, the heating of the land begins. The ITCZ begins to move to the north. Now, as the ITCZ will move to the north, the entirety of the Hadley cell in itself, that is the subtropical high pressure belt, that will also move to the north. Isn't it? We have the shifting of the pressure belts. So during the winter months, you have the shifting of the pressure belts to the south. During the summer months, you have shifting of the pressure belts to the north. This basic is clear. Anyone who is not clear in the shifting of the pressure belts? Okay. Clear? Right. Why it will shift to the south? Harmeet, change the topic. We are studying the same thing for 4 hours. So what do you want to talk about, Harmeet? Can we talk about the no confidence motion in Lok Sabha? Is that something that would interest you, my dear friend? I hope you are able to understand that this is the class of geography that you are attending. Right? Do you want to talk about the no confidence motion? Do you want to talk about the privilege motion which is passing? No? Okay. So let's come back to the topic and let's be serious here. So when we talk about the shifting of the jet streams, why is it that the jet streams, they shift? Jet streams shift because of the shifting of the pressure belts, right? Jet streams, they shift because of the shifting of the pressure belts. What is the main reason for occurrence of heavy floods this year in the North India in the month of July? Patience is something that is absolutely lacking. Okay, let me tell you. You had the Bay of Bengal branch of monsoon interacting with the western disturbances that created excessive amount of rainfall in the Himalayan foothills, because the ITCZ at that point of time was over the region of the Himalayan foothills, and that caused floods. Got it? Good. So now can we move ahead with the rest of the discussion? So when we talk about the shifting of the pressure belt, the shifting of the pressure belts basically happens with the shift of the seasons, with the change of the seasons that we have. So when we have the change of the seasons, so basically we have the entire tricellular model which gets shifted. So this jet stream, the subtropical westerly jet stream, that gets bifurcated into two different parts because of the obstruction provided by the Himalayan mountain ranges. And because of that physical barrier, you have the distinct northern and the southern branch. Now, when we have the winter season, as all the pressure belts are shifting to the south, so that is why this jet stream, which is above the subtropical pressure belt, they will also be shifting to the south. So as they shift to the south, the southern branch of that westerly jet stream, that will be significantly strengthened. So that is why during the winter months, the southern branch of this jet stream gets stronger. I hope that is clear. Now, when we come to the summer months, summer is when the heating begins. The heating is significant. Now, when the heating happens, that means all the pressure belts, they will shift to the north. All the pressure belts, if the ITCZ will also shift to the north, so imagine what can happen to all the different pressure zones. So all the various different pressure zones, they will be shifting to the north. So with the shift of the pressure zones, the jet stream that you have, this jet stream will also start shifting to the north. So this jet stream will start shifting to the north here. Now, as this jet stream has shifted to the north, can we say in the summer months it is the northern branch which will get powerful, and it is the southern branch which over a period of time starts to weaken during the summer season, because the jet stream that has shifted to the north. We can say that. So during summer, the pressure belts shifts north, due to which the jets also shifts north. As the jet stream also shifts north, so then what happens? The southern branch gets weaker and weaker till it disappears or simply vanishes. That is when the southern branch will keep on getting weaker and weaker with every passing day, till one final day it will finally end up vanishing. Now, the time till which you have a distinct southern branch, till that particular period of time, it will not allow the occurrence of rainfall. We have discussed about the reason earlier, that why the jet streams, they don't allow the occurrence of rainfall, they don't allow the mixing of the wind. So that is where, till the southern branch is there, they won't allow any occurrence of rainfall. So jet streams which tend to develop over the region of the subtropical high pressure belt, during these winter months, they lie over the northern part of the Indian subcontinent, having a distinct northern to the north of Himalayas and to the south of Himalayas branch. With the onset of summer season, as the ITCZ shifts north, the southern branch of the jet stream, that starts weakening. As long as the southern branch of jet stream is there, there won't be an occurrence of rainfall. You can have one or odd here and there rainfall events, isolated rainfall events which can happen, but there will never be a prolonged occurrence of rainfall. The moment the jet stream disappears, that is when all the winds which had accumulated, the moist winds which had accumulated up till here, all these winds will suddenly have a rush towards the Indian subcontinent. And that is when they will start causing copious amount of rainfall. And that is what we refer to as the onset of monsoon. So the onset of monsoon will only happen when the southern branch disappears. That is why, despite the factors being the heating of land and water, the movement of the sun, etc., that being more or less consistent, you will observe that the date of onset of monsoon is something which is always a surprise till the final week. It is not declared up till the final week that the monsoon can come here. The monsoon can basically come, the onset of the monsoon can happen in last May or the first week of June. Generally, the onset happens in the first week of June. So the meteorologists, they also don't know when is it exactly that the southern branch will disappear. So that is why there is a kind of an unpredictability associated with the onset of monsoon. So that is when as long as the southern branch of jet stream exists, no occurrence of monsoonal rains. As it vanishes, air, moist air, rushes towards the Indian subcontinent. That creates of monsoon. Onset of monsoon is declared when you have monsoonal rainfalls experienced over the region of the Kerala coastline. Okay. Now here you might have a question that jet stream is present over central part of India. Why is it that the winds, they are not causing the rainfall in the Kerala coastline? So follow the same logic that we have talked about earlier, that the logic or the example of a traffic jam, where we have talked about the fact that, let's suppose, if you have a jet stream here, and that creates a jam of the air in, so air would be present but there would be significant movement. The moment it disappears, that is like clearing of the traffic jam. That is where sudden rush of the winds will happen. Here also winds will suddenly start to rise. Wherever the winds get an opportunity, they will receive a fresh bout of energy. That is when the winds will hit the Kerala coastline with utmost amount of force, intensity, and causes the onset of rainfall. Okay, so that is basically the aspect. So why the southern branch disappears? Because with the shifting of the pressure belts, the entirety of the subtropical westerly jet stream, it shifts to the north, so the southern branch disappears. Then we have the impact created by the heating of the Tibetan plateau. So the Tibetan plateau has got an impact, or has got the ability to strengthen the monsoon. Okay. Now it can increase the amount of rainfall received in India. That is the impact of the Tibetan plateau. So heating of Tibetan plateau can increase the amount of rains received in India during monsoon. So basically, they can strengthen the monsoon. It is not that the monsoon is dependent on them. Understand this and listen to this sentence carefully. It is not as if the monsoon is dependent on it. But if this happens, it can strengthen the monsoon. It can increase and augment the amount of rainfall received. So when we talk about the Tibetan highlands or the Tibetan plateau, on an average, these are the highest plateaus which are present across the entirety of the world, with an average height of close to around 5 kilometers above the sea level. These are rocky highlands and rocky plateaus that we are talking about. And it is in these rocky highlands and plateaus where sufficient amount of rocks are present, obviously, and the rate of absorption of heat for these rocks will be high, because generally the rocky structure that you have, they will be absorbing heat quite significantly. So they do get heated up, and they end up creating very intense low pressure. That intense low pressure gives rise to rising air column in the region of the Tibetan highlands. This rising air column in the upper atmosphere it transitions, it moves over and strengthens the mascarene high in the southern hemisphere and then strengthens the Indian monsoon. How? Let us understand. So these are your Tibetan highlands. I'm sure all of you would be aware of this. So basically, when we talk about the Tibetan plateau and the Tibetan highlands, here, now here, let's suppose you consider the Himalayas. Here, let's suppose you consider the Tibetan highlands with an average elevation of 5 kilometers above sea level. Okay. Now, in this area, during the summer months, you can experience a temperature of sometimes 15 degrees Celsius, sometimes 17, 18 degrees Celsius, sometimes even 20 degrees Celsius. That creates very intensified low pressure. Suppose there is a particular summer month where you experience over the region of Tibet a temperature range of 15 to, let's assume, 20 degrees Celsius. Let's assume that will create a very, very intense low pressure. Even though 20 degrees Celsius is not observed, generally around 10 to 15 degrees Celsius is observed. But let's give the extremity of the situation. Climate change is anyways happening. So extreme low pressure would be created. Extreme thermal low pressure. Okay, now here you might have a doubt that why is it that at 20 degrees Celsius extreme thermal low pressure is created? In my locality, in my village, the temperature is 45 degrees Celsius, we survive. But here he is saying that 15, 20 degrees Celsius is very extreme thermal low pressure. That is where you have to understand that it is in comparison and it is always in terms of the lapse rate that you have to consider, the height at 5 kilometers. At a height of 5 kilometers, you don't experience 20 degrees Celsius. Right. So, for example, I'll give you the case. Let's suppose somewhere in the northern plains, if let's say you experience a temperature of, let's assume 40 degrees Celsius. During summer months, if you have a dry lapse rate, what will be dry lapse rate? Let's assume is at the rate of 10 degrees Celsius per kilometer. So, at a height of 5 kilometers, what will be the temperature here? Minus 10, perfect. So here you will be experiencing a temperature of minus 10 degrees Celsius. Whereas here you have a temperature of 15 degrees Celsius, even 10 degrees Celsius, even 20 degrees Celsius. So that is a very high amount of temperature. Now, when we have a very high amount of temperature in comparison and a very intense low pressure, so that intense low pressure will create a rising air column. Let's assume this is your equator. Let's assume this is the region of Mascarene Islands. So here it will create a very intense low pressure. Now in the region of intense low pressure, what do you have? Air will rise up. Air will rise up and then the air will diverge. Right? The air will diverge. Now the air will diverge in all different directions, owing to obviously the Coriolis force, etc. So here, if you can look at it and if you can have a view about it, so basically, imagine that the air is rising up here. Once the air reaches the upper atmosphere or the upper region of troposphere, it will be diverging in all different directions. Right. Now, one portion of these that will take a bend, that will be moving over the region of India in the upper atmosphere. These are your upper atmospheric winds or upper tropospheric winds. These are the upper tropospheric winds. So here, that wind pattern we will take as notice. So this will basically rise up here. It will move. It will actually follow a direction. If you have to imagine, it will follow a direction somewhat like this, what is referred to as the Kolkata Hyderabad axis. So it will follow a direction. It will uh, rise, bend, follow a direction like this in the upper atmosphere. This is the upper atmosphere wind that we are talking about. And as soon as it crosses the equator, then what will happen? It is basically much more bent in general. Then what will happen as it crosses equator? It will bend to the left. It will continue to move. It will continue to move up till the region of the subtropical high pressure zone. That is the region of Mascarene High. It is in that area of Mascarene Islands where it will sink. And that is what will be observed. So here, this is something which is going to move. It will cross the region of equator, bend to the left after that, sink in the region of the Mascarene Islands. When it does sink in the region of the Mascarene Islands, that will, in a way, reinforce or increase the high pressure at the Mascarene Islands. Increases the high pressure in Mascarene Islands. Now, if the high pressure in Mascarene Islands is strengthened, means what? It will start driving more winds. It will start pushing in more winds. All those winds, they will cross the equator. And these are the surface winds I'm talking about. They will cross the equator. More of these winds, when they cross the equator, means they will bring more moisture overall. So that is where you will have from the Mascarene Islands, more winds will be driven. They will be crossing the region of equator, coming over to India, and end up causing sufficient amount of rainfall in the process. They will cause sufficient amount of rainfall in the process. Now, this upper altitude movement of the wind, if you think about it, this upper altitude, this is your upper altitude movement, upper air movement of the wind. So this upper air movement of the wind that you see, that is basically going to move at a speed of close to around 90 to 100 kilometer per hour. And it's generally, the direction of it is considered to be east to west. That is the general direction. That is where this wind is referred to as, with a speed of 80 to 100 kilometer per hour. So that is where this is referred to as a temporary jet, that is the tropical easterly jet. That is what is referred to as the tropical easterly jet stream. So that tropical easterly jet stream comes into existence during the summer months due to the intense heating of the Tibetan highlands. Once this tropical jet stream comes into existence, it will increase the intensity of high pressure in the Mascarene Islands, and that is what will drive more moisture laden winds, will increase the amount of rainfall. So these are your upper air tropical easterly jets. These are your surface winds. This is upper air movement that you see. This is what is tropical easterly jet. Why not northeasterly? Because as I told you that the general direction of movement is basically much more bent over, and the general direction of movement is somewhat like this, and that is why it is referred to as a kind of an easterly jet. Okay, so that is basically your tropical easterly jet. So overall, during the summer months, these rocks, they become very, very hot. They form an intense low pressure region over Tibet. Now, resultantly, the air rises and diverges from a height. The divergent air goes all the way to the southern hemisphere and sinks over the region of Mascarene High. So, this upper air movement is sometimes referred to as the tropical easterly jet. It forms an important cycle which strengthens the monsoon by increasing the strength of Mascarene High. Increases the strength of Mascarene High. So why will it only fall over the region of Mascarene High? Why not somewhere else? That is because in that region of Mascarene High and the region of Mascarene Islands, there is already a high pressure zone which is created. High pressure, that is the dynamic high pressure, the subtropical high pressure. And in the region of subtropical high pressure, you already have a sinking air. So that is where it takes a part in that sinking air column, and that is where it sinks along with the other air column as well. That is why in the region of Mascarene High. Okay. I hope, Saranya, that is understood. Okay. Now, do these winds encounter Himalayas coming from Tibet? No. So these winds, they reach the tropopause very easily because they are rising up from the region of Tibet, which is at a height of 5 kilometers. So they will reach the region of tropopause very easily. Then we come to the portion of the Mascarene High. This is simply the high pressure which is present around the region of the Mascarene Islands. So the high pressure around Mascarene Islands. High pressure around Mascarene Islands. So this is the subtropical high pressure that you have in the southern hemisphere. Now this becomes the driver of the monsoon winds. Locate Mascarene Islands in the map, even though I have located it for you, but try to look at it from the atlas as well. So this high pressure is the driver of the monsoon winds because winds originate from here. They will move towards the region of equator. That is when they will bend and hit India from southwest direction. So we can say that stronger the Mascarene high, more will be the wind movement. Weaker the Mascarene high, weaker will be the wind movement. Greater the wind movement means more rainfall. Lesser the wind movement means less rainfall. So, in a way, can we say that the strength of the Mascarene high pressure will end up determining the amount of rainfall received in India during the monsoon season? So, here, this is a zone of high pressure which exists around the Mascarene Islands in southern hemisphere, and hence region is referred to as Mascarene High. Now, during the monsoon months, when it is winter in the southern hemisphere, this region of high pressure is the source of winds which travel across the Indian Ocean to reach ITCZ, which lies over India during the summer months. Stronger the high pressure of Mascarene Islands, more is the rainfall because more is the wind. So, any factor which can influence in a way the strength of the Mascarene high pressure, that can influence the Indian monsoon. Any factor which will increase the high pressure at Mascarene Islands will cause more rainfall in India. Any factor which can weaken the strength of the Mascarene high pressure will weaken the amount of rainfall received in India. Okay, So that is what we will study when we talk about the impact of El Nino and La Nina. So El Nino and La Nina circulation, they also strengthen and weaken the masculine high pressure. That is why they cause greater or lesser amount of rains received in India. Okay. ITCZ, sometimes it does disturb. So, when what happens is sometimes the ITCZ does lie over the region of, does come across over the region of the Tibetan highlands as well because of the heating. So, in that case, the intensity of the tropical easterly jet is much stronger. Otherwise, the ITCZ doesn't have much of an impact. Okay. So that is where we'll restrict it today. Kindly do the revision of this, and then we meet again on Monday, and that is when we will continue further. Tibetan Plateau develops low pressure during which months? During the months of the summer season. So that is when you will observe, let's suppose in the previous winter, if let's suppose Tibetan highlands have received high amount of snowfall and high amount of ice cover. So during those years, the summer won't be very hot. So oftentimes the heating of the Tibetan highland is dependent upon how much cooling has happened during the past winter. Subramania, as of now, all these details you won't be able to find in a particular book. So I would suggest to you to revise the portion from the PPTs itself. Garvet, sometimes winter also brings rainfall in my region, Haryana, because of western disturbance. We will talk in the later portion of it. Okay. And again, guys, I would on the verge of being repetitive, I would urge you, please have the revision of it. You won't be required to open up the book, and you won't be required to refer to any other source of material, because more than that, more detailed aspect we are covering in the class. So please take the advantage of it, and that will give you an edge over your competition. This exam is a competition, understand that. So that edge, please don't let go of it. Okay. Right. So please don't let go of that advantage. The more you revise, better you will get at it. Everything is driven by two basic aspects of temperature and pressure. If you understand those basic aspects, the sixth and the seventh module that we have covered, all of this is simple follow up of that doubt. Okay. How winter impact Tibetan plateau heating? So that is basically when you have, during the winter months, let's suppose lot of snowfall has occurred, very thick ice sheet has been created. Now it will take some time for that to melt. So it will melt by the late May, maybe early June. So then suddenly lot of heating won't happen. Imagine if there is a less snowfall. So there will be immediate amount of heating created, isn't it? No, tomorrow we don't have an extra session. We'll try to take a look at it next weekend and a weekend after that. Tab lecture or live class recorded lecture should be used for revision after class. As of now, as long as the classes are going, please revise with the help of the recorded sessions. After the classes are over, after the 25 modules are over, take a look at the revision from the tablet. That will be the ultimate source. Okay. How can we study to solve questions? Okay, so that is not the type of questions which have dominated. You still have many basic questions. Prelims results are not decided based upon those random questions out there. The problem arises when, as candidates, we start chasing those random questions. So don't chase those random questions. Cover the basics, and we'll talk about it later, that what is the pattern of prelims as well. Generally in prelims you will always find 40 to 45 basic questions which are coming from the basic concepts. There will be 20 to 25 extremely random questions which will be there. The problem arises that we think about it that 45 we will do correct, but it is there that we basically commit mistakes and we are out of the race. Okay. Now Mayank, but sir, the two statements are looking contradictory. That is, the sinking air creates high pressure, and the air is sinking because it has become heavy because it is cooled. You are saying that sinking air becomes hotter due to adiabatic compression. So, see, the high pressure which is created is not always thermally driven. The high pressure can be created due to the aspect of the dynamic pressure as well. So in a region, let's suppose due to any event, even sometimes jet streams can end up creating a zone of sinking air. So wherever, let's suppose you have that zone of sinking air, it will be high pressure. But sometimes as the air starts sinking, it will get heated, it will get compressed. So for example, the subtropical high pressure belt, it is very hot, it is amongst the hottest regions across the planet, but it is a high pressure. Why? You have sinking air. That is because of the dynamic factors. I hope you are able to understand that. Gulam, I hope you have revised the earlier portions now, and I hope it is understandable now. Uh, Kamal, see, that is the crux. If you approach the basic, it is more than sufficient to understand. And is there any other country having such a very influenced monsoon? A complete reversal of wind? No. So that is something that you will observe. You have pseudo monsoons which are referred, which are experienced around the region of the Caribbean islands, etc., where you have partial reversal. But a complete reversal is not something observed other than the Indian subcontinent. So yes, if you consider the region of Bangladesh, Sri Lanka, etc., there also you will experience it. But other than the Indian subcontinent, no. Good, Gulam. Now you would be able to understand that. And Mustafa, my mail ID, you would be having. Anyways, this is the mail ID. Why is it that you have a wave pattern in the jet stream? That is because you have the cold air coming up till some region and warm air coming up till some region. So it is not consistent. So in certain areas, cold air will come southwards. In certain areas, warm air will come northwards. So that is why the wave. Okay. Tropical easterly jet streams do not stop the wind movement. No. They are moving in upper air. So how will they stop? Does the easterly jet stream contribute to retreating monsoon? No. By that point of time, it disappears. Okay. Should I consider it as high pressure or low pressure and cool or heated conditions? Both are separate. Low heated and cold conditions does not necessarily mean a high pressure or a low pressure. Okay. So that is where we'll end the session for today. So Mascarene Island is under which country? So you already received a reply. It is under the French jurisdiction, right? Are there two monsoons always every year? Yes. Pura, yes, we are working on that. There has been some incident due to the floods which have happened in Delhi. But let's see, we are working on that incessantly. Tarun, I'm not able to score good in weekly test, even though I think I understand these concepts. What could be the reason? So analyze that, Tarun. See, you are your best judge in your case that what is going wrong in that case. So analyze. So ideally, after giving the weekly test, classify the mistakes that you have done into two parts. The mistakes can be created either due to lack of content or due to a misunderstanding or a silly mistake. Now, wherever silly mistakes are happening, there is also a pattern. Silly mistakes can happen because I have not read the entire statement carefully or I have misunderstood the statement. So that means greater practice will do the job. If there's a lack of content, I will take a look at the explanation, improve my content. So that is the approach you should always follow. Okay. Charan, you said easterly winds are sink and masculine high, and why the winds come to India, it can go for another direction. So, because as they sink towards the region here, then the masculine high will give rise to the winds which are basically going to be directed towards the region of ITCZ. If you are asking why these easterly winds come over to the portion of India at all, so you have to understand that they diverge in all directions, but the other ones they will not impact the monsoon. We will only study the ones which will impact the monsoon, isn't it? Right? Tamal will try to provide more of them, but you will find such lectures being provided in the tablet as well. In tablet also, we have entire series of lectures. In prelims, Kumari, generally you will find around 15 questions which were asked this year. And how many percentages from basics? Around 10. Out of 15, around 9 to 10 is from the basics. Okay. No, the entirety of Rajasthan is not a desert area. So that is where we'll restrict the session here today, guys. We meet again on Monday. Take care of yourself, do revise, and relax as well. And till that point of time, goodbye. Thank you, and have a good night.